this probably will not work, which is why I'm doing it. Because I've changed some things in the compiler lately. Yep. There's going to be a couple things that I need to change. Although I'm not sure why it's giving me that error. I'm a little confused. Like, does this literally not? Oh, never mind. Right. I haven't done that part yet. Do this. Really? I didn't expect that to work. No. So the assert is just silently tripping right now. That's fine. I can live with that. So the deal is, we've changed some rules about how this is represented internally, and now when we go store the fingers, it's, yeah. So I just have to realize if this requires a data segment patch. So maybe I want to step here. It's been a long time since I looked at this particular code. Wow, chat is quiet. Nobody's saying anything. Maybe the stream isn't even working. Kind of want to look at this. So this is on line 182, and this is Whoops, that's not what I wanted. Oh, well. Let's try it. Somehow I confused myself. It's fine. All right, I'm going to reload my Twitch page just in case. Just in case people are saying all kinds of great things and the World Wide Web is not showing them. Okay, so we might accidentally stop in the wrong file, etc. No, we didn't. Okay, great. It's a literal, great. Whoops. Yeah, well, you just said great things. It's a literal. Okay, this is presumptuous right here. It's just not handling the new literals that we have. That's fine. Actually, this should probably be removed. See what happens when we do that. Okay, if it's a pointer literal, then we get down here. Let's just say PL type. Oh my gosh, this is a long name. So we're going to do this. Going to do that. Come on, learn to type. Learn to type. So we should get one of these now, hopefully. Yeah. which is good. What happens if we try to build the game? Does it have these? Probably. Maybe not. Oh, there we go. Well, it's upset about something that we changed. That's pretty weird, though. Do I want to try to debug that separately? Because that is probably related to this number flags related thing. That we did here. Let's just double check. I bet this goes off. Right? No. That is very strange. I kind of don't want to, like, this isn't going to be fixed. I should debug it. I should debug it. I should debug it. Are we using this bytes? Yeah, okay. How many microservices? I think if there's one service for every character in the source code of the compiler, then you're making sure that all characters have their diversity respected and that none is undervalued in the final product. Like, what if this comma had a microservice, but like this semicolon didn't have a microservice? That wouldn't be fair. That would be downright bullpucky. So I think every character of the source code needs a microservice. And then the microservices coordinate to make an emergent Pratt parser that's composable and then you'll be able to compile the compiler if you have only a supercomputer from the year 4088. I mean, and these are the issues. These are the issues that people don't think about. Like, what if the computer is doing the semicolon, right? And it starts doing, so first it does the dot on top of the semicolon, and then it's about to do the comma part, right? But then what if we need to throw an exception there, right? Like, what if we just decide that we don't want to finish the semicolon right now? We want to go do this down here. What about that? I ate way too much chocolate yesterday, but that's not going to stop me today. Every character being an object is actually suggested in the Gang of Four Pattern Design Patterns book. Well, that is why you should not read that book. Can you have some chocolate too? I'm sorry, but I'm too busy working on a compiler to invent Wonka Vision, all right? If I had Wonka Vision, you would all get chocolate. I mean, you could invent Wonka Vision, and then you would have chocolate. Do not let me stop you from inventing Wonka Vision. Don't wait for me. I have not shipped the new feature I taught. Like, guys, new features are sometimes hard to do, or it's a decent amount of work. Just because I tweeted about something like 2 days ago doesn't mean I did it and shipped it. I mean, I need to make at least 50,000 more microservices before I can ship that new feature. I don't know what you're thinking. All right, we are making some tea. It is very strong. We must not oversteep it. That would be a grave mistake. Yeah, easy to do doesn't mean I automatically do it either, because I have a lot of things that I need to do. For example, the thing that I'm working on right now, which actually is a precursor to that idea. It is on the roadmap to that idea. Okay, I actually, even though what I most directly need to do is make these. No, you know what? We're going to do these. We're going to do these. So okay, well, I'm just going to do one of these. In the case of either of these literals, down here, we're just going to do the same thing. We're just punting for now. Then we should actually get an error later, because the thing that does data segment patches should be like, dude, I have no idea what the hell this thing just is that you gave me. Yeah, see? Oh, it's actually not what it's complaining about. Oh, well. Yeah. Lol. Cut and paste will kill you. All right, there we go. We errored too early because we didn't say that we handled it, so it's unhandled. Okay, so now it's complaining here. Okay, this means that we have some robustness missing in our compiler, some developer kind of robustness, because it should be complaining like, hey, you told me to make a data segment patch and I don't know what the hell this thing is, but it didn't do that. Maybe x64 backend will. Let's see. Okay, so these are basically the same. These are just saying, hey, there was a data segment patch that wasn't handled by anyone, which is better than nothing. So I have to go into both of these backends and make that work. Yeah, we may do another discussion with Casey about movie or TV show stuff soon. Okay, the T, we might have a T emergency already. Copy and waste. See. Maybe I'm pouring it too soon. Maybe not. It's pretty okay. Could be a little stronger, but it's all right. Okay, so basically these data segment patches are just saying, hey, there's a thing here that we're storing in this memory, and that thing is actually a pointer, and you need to tell the object file about that, because when this thing is loaded, that pointer needs to be initialized to its target value, right? That's how all that stuff works. So we are not currently doing that for this type of thing. We can go in and there's probably a couple loops. What's it called? This is called patches. So I hate trying to find, oh, it's probably here, right? There's so many patch lists right now. We need to like unify some of these. There we go. So that's one loop. And this is another loop. This one is just looking for string literals. I don't know why. I don't know why we aren't erroring here. Honestly, that's freaking me out. Did I mess up the copy paste even further? I mean, no, we're setting it to literal. That's the expression. We're adding the data segment patch. So like what, I'm just going to run and hit this assert. And we're going to see what it's complaining about and where. Oh, you got to put the x64 because LLVM is garbage about reporting asserts for some reason. I need to fix that someday. All right. Wait, it didn't do it either. Are we not even running the frickin' program? Oh, that also includes a goddamn LLVM header file, so assertions don't work there either. Dude, I want to punch somebody. I'm not a violent person, but sometimes I just want to punch somebody. All right. So like we actually can't, like assertions don't even matter in this file. What is, it's like, okay, we've got, there's a control M. We have to delete that so that it'll maybe then, see, it's like always clicking on a different line. Like way far off. Like next time somebody on Twitter tells you software is totally fine, it just works great. Can I click now? Yeah, okay. Now I can actually click on the circles and the click position is equal to the circle position. You see, before the click position was not equal to the circle position. Like, I just can't take what anybody says with a straight face anymore. It's just so crazy. Like, people assert things that are completely contrary to the reality that I live in about how well software works. It's like they don't know what the definition of working is. All right. So this is a literal, right? So why didn't we hit the other thing? Oh, because we're assuming, right here, we're saying if it's a literal, it must be a string literal. Okay, this is, right, this is the second loop, deloop. And I think we want to handle, yeah, let's just do this. We'll think about cleaning that up later. All right. So we'll get the literal again here. So we have a pointer literal. All right. Unhandled pointer literal. So now we're getting to the right place. Great. All right. Unhandled pointer literal. Now we got to handle the pointer literal. All right, so what's it called? Okay, so if it's a global symbol, we do something. Still in Vegas? No, I'm not. Okay. Well, these are two different cases, and I gotta handle both of them. For the global symbol, let's go. Generic expression pointer. We're going to assert this. Export global symbol for non-constant declaration. You know what? Let's just do this. Hold on. It's got to be frickin' objwriter method. I need to DC++ size all of this. Okay. So I need to clean up this fucking thing that got done too. So annoying. So annoying. It's not how it should go. So wait, do we iterate over this again later to actually do the relocate? This is not even the thing that does the relocations. Oh wait, yes it is. I have no idea what's going on here. Oh, right relocation right here. So we just need to set adder to the right thing. Code like this is annoying when I haven't looked at it in a long time because I don't remember which symbol index and all this. So like, God. Come on, guys. Come on, guys. All right. I'm going to put this in the to-do to clean this up because, like, after shipping the beta, that just has to go away. Okay. Do I have a way to visualize a syntax tree? No, I don't. And it's annoying. The problem is the syntax tree is really complicated and you know, I change it a lot, so I don't want more friction about changing it. And I just don't even know what would be a good visualization because the problem is usually I need to look at a lot of things to figure out what's going on. And really, you know, honestly, this is just stuff that the debugger should make easy, but doesn't really. Like, why doesn't the debugger just automatically visualize data structures? It's the year 2020, you know? But no, the most important thing we can do on our open source software development teams is figure out rules about who's allowed to stay on the team and who isn't. We're not going to actually work on anything to make it better. Am I going to make a debugger too? No, other people are doing that. I don't need to do that. I mean, they're probably not going to make something that visualizes things the way that I would like to. So I'm going to do a program visualizer, but I'm probably not going to do a debugger. There's going to be multiple other debuggers that are better than GDB or Visual Studio or LLDB. What if I decide that the word problematic is problematic? Then what are you going to do? All right, so I'm doing this garbage that we have to clean up. I'm going to put for here right now. Okay. So we have this addend, and then we do this same redundant garbage here. And then we say we handled it, and then that causes dude. Sometimes I am very disagreeable about code that other people write. Okay. All right. So we're just going to see if that, there's all sorts of reasons why this could blow up, like I'm not even doing it at the right time. Because of C++, I have to put this in a header file now. What a garbage. Then I have to recompile my whole program because I put something in a header file just because I want to inline it and use it from two files. 1970s technology. All right, so pointer target, right, we don't have that. This is yet more redundant. Okay, adder is the, like, why do we have something called adder at this point? Like, address of what? There's like 7 addresses in play here. This is totally going to get rewritten by me. Okay, I messed this one up. This is info. Okay. Okay, it's no arrow, no arrow. All right, I forgot to use this thing that I passed in. What is the particular problem? The particular problem is that it was code. So originally I was doing this stuff and just targeting Windows, right? So let me try to find, what's the thing called? Oh, it's GNU linker. So originally I just had like a one-liner, which was like, hey, just do this, right? Just write, because the way these file formats work, at least on Windows, is you just write like the offset into the target location, and then in the target memory, right? And then in the relocations table, you write the symbol that should be poked into that address when you link all the symbols together. And then at link time, the value you put in the memory is added to the value there. Now, that is apparently not true under some conditions in Linux, whatever. And so you can't do it that way. And so the right thing to do is to maintain a reasonable, simple API that just retargets at the end, or actually that just puts 0 there all the time, because honestly, I don't think it really, we don't need to do it this way. We just did it this way because Windows lets you do it that way, right? And instead of doing that, it's like every single time that you want to do a relocation now, you have this if-def. You either put 0 or the thing that you want in there, but then you also have to put the thing that you want in this other variable that then gets passed down to this other function that gets used in case it's Linux. It's just a lot of garbage complexity for no reason. Like, this all should be really simple, and it got complexified. Now, this is actually a common thing. And then, of course, because it's more complicated, it complicates the job of anyone who comes after. Like, because I haven't done this code in a long time and I'm barely remembering anything about this at all, it's a high probability that I'm making a mistake doing this. And even if I know what to do, I might make a copy and paste mistake because we have this redundant value. Or maybe these aren't supposed to be the same all the time in some way that I don't remember. It's like, it's way too much, right? All I want to say is like, add a relocation for a particular symbol at a particular memory location. And instead we have like this, right? Plus stuff down below. And this is actually, so this is a thing that happens often in software development though, right? It's like you do something that's originally simple and then you need to add some functionality and stuff, but you don't then, like sometimes when you add the functionality, it gets a little more complicated. But you don't like poop on the code and leave it needlessly complicated. You figure out then what's simple and do the simple thing that's easy for people to deal with. That's vitally important. And the fact that most programmers don't do that most of the time is actually the root cause of why most software projects ultimately fail, because the complexity becomes unbearable, right? And I'm just angry in a sense. I'm more angry than I usually would be because I wrote this code originally, you know? And it's like, it just always feels this way when someone else poops on your code. Now people weren't trying to poop on the code. They were trying to help, right? I mean, they were adding functionality that objectively in the end makes it better because it works on another operating system where it didn't originally, right? So like, it was an attempt to help here, but it actually also did damage while helping in a way that was really not necessary. So now I have to go back and like frickin' you redo all this, and it's probably about as much work for me to do that as it would have been to just do it in the first place, right? So, like, it's just the Shakespearean tragedy of software development happening. But this is why people need to be good at what they do and like on the ball and having high standards, right? Can I not make a macro just to reduce this? Yes, of course I can change it. It's a computer program. Right. The point is I'm working on something else right now. And I don't want to go, like, I'm breaking parts of the compiler. So I don't want to go off and do another thing. That's why I put it on the to-do list. All right. But this is the thing, is like there's really a lot of things that need to be done. And so just think about this if you're on a team, right? If you claim to be checking off bullet points on the to-do list, but then you're adding more to-do list for other people later, you're not really helping, right? You're not really helping. So, that's the thing. That's the thing. Do I think it's because people are not empathetic? I think it's a variety of things, right? So when you're new, you don't really know. Like, if you're a newer programmer, you don't know how to be the best programmer because it just takes years of getting better, right? That was legit painful. Is it really that much louder? Because it looks like, when I look at the volume scale on OBS, it looks like I'm close to top volume most of the time. Anyway, when I'm talking. But, okay, well, it clips badly. All right. Stream is kind of low sound. That's weird. OBS must be doing something really weird. I did not intend for it to be that loud. All right. We'll try to figure it out. We need to do a test stream sometime where we figure out why it's such a loudness differential. Um, anyway, yeah, like, and this is just why it's so tiring sometimes, because it's like, dude, I'm trying to do something else. Why are you making me do this thing that I don't even, ugh. Don't yell right into the mic. I need to yell right into the mic in order to communicate effectively sometimes. That is just a thing. There are some situations that are only correctly represented by me doing that. I wasn't even yelling, actually. Like, you're saying I'm yelling into the mic, but I wasn't yelling into the mic. I was just like, speaking very directly into it. All right. So, all right. So, how badly did I get this wrong? Well, that's one way it could go wrong. Dude, I'm gonna fucking... I can't assert anywhere in this file. It's broken because, again, someone made a decision that I don't agree with. That makes me angry every day that I have to work on this file. All right. We just have to... Assertion doesn't work, so I'm just going to break here. All right. So final, because we... No. All right. So what is expr? It is a declaration. Oh, this function should actually... All right, let's do this. I believe it should always be a declaration when we get here. Can't you like undef assert and then include assert.h? I think I tried that at one point and it doesn't work for some reason because it's like something else is wrong. I don't know. I spent like an hour trying to figure it out and I couldn't do it. I might have been stupid, just like I am when playing puzzle games sometimes. All right. So we managed to compile this, but it looks to me like we didn't put the pointer patch in the right place, which is no surprise given how garbage this is at this point. Like, it was always confusing even before this happened, and now it's like extra confusing. There's several things that, like, this whole thing needs to get refactored very heavily because some of the original decisions that I made didn't make that much sense. There are some things that I did where I was like, I'm just going to spell this out the long way because I don't want to make a premature abstraction. That ends up being wrong. And now that I know how it should go, it's like, okay, it's time to make that abstraction, right? And I haven't done that. So much work to do. Okay. What am I looking for? You know what? Get the goddamn LVM header file out of ObjWriter. I'm just going to make that top priority before even doing anything. After this works, because I don't want to derail from this, it makes me so unhappy. I'm going to Marie Kondo that and just be like, look, this thing that makes me unhappy is going to change. I don't care. I don't care about anything else. I don't care about shipping the beta. All right. So that probably works better. Of course, we wouldn't know because asserts don't work in this file. All right, well, it's still, I don't know. Let's see. Okay, we do have it. Okay, it does have global storage. Section number 4, base address. So these numbers kind of make sense. Okay, we're not on Linux. So we're writing a relocation in symbol index. Oh, did I say int symbol index? No, we just didn't set it. Okay, so symbol index. All right. I think we just do this for now. Although that is also very scary. All right. Do we just... Okay, see, this is already wrong. Yeah. I missed, so where are we? Yeah, okay, so I just kind of copy and pasted this, and that's of course wrong. Again, this is one of these things that we should factor out and make cleaner. I copied it from a previous thing that couldn't be in the BSS segment, but this can. Oh wait, we shouldn't. This shouldn't be able to be in BSS. That's the mistake. That's the mistake. So the thing that figures out who has non-zero init data. Of course, asserts won't go off. I need it. Okay, forget. We're going to do it right now. I don't care that this is a derail. This makes me so unhappy. All right, so I have to figure out. This is like even being included by somewhere else. How about if I go to assert here? Okay. Where is this? No, see, so the actual assert macro is fine. It's like something else that LLVM does that screws it up that I don't even understand. So, all right, where is it? One of these files, oh, it's this thing right here. Like, this doesn't even make sense. Wait, this is only happening not on Windows, so that's not, oh, it's this. It's this file. Like, what? Why are, see, this is another thing that people end up doing. Like, look, LLVM is simply not to be an integral part of this compiler, right? It's a thing that we're using in a compartmentalized way to very usefully compile machine code, right? Here, let me, I'm thinking about a lot of different things. I'm just going to put a frickin' assert false here because I want to know when asserts work again, right? First of all. So there's two problems. One is LLVM is screwing up assert. Second is, why is LLVM being included here anyway? It's to define some constants that debug files use. But like LLVM doesn't own those constants. They're like just constants that everybody knows. So we're like including somebody added this file as a dependency. Like, so we're now depending on the entire source tree of LLVM in order to define a few constants that we are using, right? So it's not the kind of thing you should ever do. It's the kind of thing, however, that people do because the current engineering attitudes that are being taught do not tell you that this is bad. Okay. I don't have to SVN blame. Yeah, it's fine. I know when and how this happened. And again, it happened in the process of adding some useful functionality to the compiler, but there's a fine art to doing that without also adding radioactive waste, right? And that's all. So, you know, I'm glad that some of this work was done. Some of it has been very annoying. All right, so, and I'm not even going to try to sort out the macOS one. Like there shouldn't just, the word LLVM should not be in this file. Let me put that in. All right. So this thing, no, that's just a no. And I bet that we don't compile without that. No, apparently we do. Great, because those, I guess, were already included. Oh, no, sorry, that was the non-Windows. Never mind. If defs are confusing. It's this one. It's these ELF constants that we have to get rid of. So I need to find a source of these constants. I don't really want to copy it. What's LLVM's license? Is it like BSD or is it like GNU or what? The word, not the world. The world, I mean, LLVM is about as big as a world. It's true, but... all right. So basically, we want to define all these constants for ourselves. And they just get used in places like this when we're putting stuff in. All right. I'm looking for some place that has authoritative versions of everything. Like SHT prog bits is one. Okay. So here is, I don't even know what is this. Mini rig he, what is that? It's somebody's kernel that loads ELF files. Linux had a C header file elf.h. Yeah, but what license is it under? I don't, yeah. I don't want to copy, even if it's just constants that everybody knows, I don't want to copy them from something with a weird license. If I look at the file, it doesn't actually have dependencies on any weird LLVM things. Yeah, that's fine, but in practice, including the file from the LLVM source tree requires LLVM, right? So LLVM license. I suppose I could have looked at that. Let's see. Let's see what the license is. Yeah, no, we're not going to do that. Fuck you. No. I mean, it's fine to do that when we're actually using LLVM, but we're not going to let that intrude into the rest of our program. All right. Well, it's probably 0. I don't know. Eight. So the problem that I have right now is I left the compiler in a non-working condition, and I'm also going to screw things up here, but that's just the cost of doing business. Two. Let's put that in. That might be useful. 3. Let's put them in order. Okay. Alloc 2. Oh, it's a flag. SHF write OX1, execute for. Right. So that's some of the constants that we are using. Strela. Strela is what? 4. But there's also a rel. I'm going to put that just so that we know that there's a potential issue. Like it's so, like, I guess these are in alphabetical order, not numeric order. What are we missing? 2, 3, 4, 5, 6, 7. Note hash dynamic. All right, whatever. License appears to have changed. Yeah, I'm not gonna do that to copy some constants. Like, you guys don't understand. Like, that's just not a thing. I'm not going to undertake. See, you don't want to undertake a legal obligation for the entire history of the compiler in order to get some definitions of some constants that are defined by consensus. Like, it's just not a thing. You know what I mean? You have to understand that that license is a thing that you need to comply with forever as soon as you do that. It's not worth it. Okay. So now we have some other stuff that we need. Well, we might be missing a couple of those still, but there's these other things. ELF64 Rela and ELF64 Sim. All right, well. Oh, is that a struct? Let me look at the actual code. Yeah, that's a struct. All right. I mean, all right. See, I don't want to copy this necessarily because I don't, like, this is code right here and I don't know what the, like, I want to find the original ELF documentation. This is a copy of someone else's probably. Non-exclusive worldwide royalty-free license to use the information. No other license is granted. Makes no warranty. All right. See, this is probably fine. This is the kind of license you want to see, is like you get to use the information. It's fine. We're not forcing you to put this notice somewhere or to give people code or whatever, right? However, the name of the struct is not really, or maybe it's just not searchable. All right. We're going to need to use these. unsigned care. All right. Great. ELF32 eder. Okay, we use that one. But we're allowed to actually copy this information according to that thing. We might need some of those. No 64-bit in this file. Do we handle 64-bit? I don't even know. I'm just going to start using what's in the file. Oh, these are ELF64s. This is the wrong spec, I think is what we're saying. Okay, here, this is the same. 1998. Wow, only 3 years and they did ELF64. They were kind of early, I guess. All right. This is all that we need here. I'm going to put this on this window over here. Okay, ELF64 adder off. Half is still 2, interestingly. Word is 4. S word is 4. Like, it's so silly that everybody has to make all their own names for all these things. Because they can't change. They're not allowed to just use... It's just C++'s fault for not setting these up. That's the unsigned. SX word is signed. And then unsigned care. All right, so... file header. That struct that we just did is now this. They didn't bother to then there's the shitter. Whoops. And I assume we need ELF64 sim, right? Oh yeah, we do. And ELF64 rel and rela. Should I compare the spec I found to the LLVM header as a standard check? I do not even want to look at the LLVM header because I just don't want copyright danger on this. So if I make a mistake, cancel software. Okay, well, I goofed somewhere. Oh, not really. There's just more things we didn't get. Those are also in the spec. STB Global. This one's searchable, which is great. Okay. This is symbol visibility. Right? So weak. Lose if people have to go to the loo. I don't know what these are. Like, none of these are ever going to get used. So we're just going to do this. Symbol types. And then we have this loose and who's stuff again that we're going to ignore. All right. That should get us a little further. EV current. You can't run your electric vehicle without EV current. All right. Okay, do you want to see a hilarious thing in your spec here? I'm searching the spec for EV current. No definition for it in the same way, but it says in text, the field has the value EV current, which is defined with the value 1. So it's telling you EV current is 1, but like in an English major way. Like, what the hell is that? And it's also a useless field, right? Because it's just, obviously there's only one value. All right. Elf magic, elf data, etc. Uh-oh, we're not seeing elf magic. Okay, eident lmag 0 through lmag 3, identifying the file as an elf object file that contains the characters 7f, el, and f. All right, so okay. So I think I just define this as a string. I don't know how I do. How do I do? Can I do a constant in C++ like that? How do I put a 7f in a string in C++? Is it \x 7f? Like that? Oh God. So it's going to keep parsing the constant if I don't break it up, is what you're saying. All right, great. Elf data, elf OSABI. Elf data to LSB. This is just endianness. And then elf OSABI none is not defined in this file. It defines sys5 hpux and standalone. I'm going to assume it's 0. Let's actually look for this. See, this is the OSABI definitions. It's like Rust says it's 0. And you know, that means the borrow checker verified that it's 0, so I believe that. Right? That's pretty safe. Can't change it unless you get a mutable reference. Okay, we still need a few more things. ET phone home. ET rel. ET none, 0. I'm going to just put a few of these in. I'm actually going to put comments. Okay, and then EMX86, that is not even a thing in here. So that's something else. What? MX ETREL, and then an operating system specifier. This is in the top header. Okay, so we can sort of figure out what this is. This is in the E header because this is like where the magic goes. I don't know why it's got 16 bytes for magic number. Oh, it's this stuff. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. Okay. And then object file type is etrel. Machine type is emachine. So maybe if I search for emachine, we'll find the definitions somewhere. Indicates the values are defined in the processor specific supplements. All right. Oh yeah, see, Google said list for me. All right. Hey, SCO Unix, I'm sure that has no copyrights. glibc, we're not touching that. LLVM, we're not touching that. EM none. EM. Is that what we were looking for? Was an EM? Yeah, let's just look for that. Define EM x86-64. Not looking in the Linux kernel. Where do we think is going to be a good public domain place to get these? Something from Stanford? Let's see. What's the license on that? No, I don't want the file. What is this? It's a new operating system designed to minimize the amount of trusted code in a system. What is the license on your code? Git. You linked me to Git and not your actual site. Okay. I just clicked on it because I was like, that's going to be where it is. Oh, thanks for telling me what Git is. README. What is the license on this? I don't care about any of this. Oh, someone is linking me. It's a footer in this spec. Really? Maybe it's not searchable. Follow the one. Okay, sorry. It didn't look like it, but... Ah, footnote. Footnote. The value of this identifier is 62. All right. I mean, that's very English major of you, but we'll do it. We'll do it. Yeah, I just missed it because I was looking for a table with a bunch of things, but they were just like, nah, we're just going to define this one machine. That's all. We don't care about other machines. All right, so we finally compile. That's good. Before we get a big head, let's... put all this stuff into a file. Really, I should start making a folder just for back-end stuff or something. All right, we've got too many windows open. All right. Great. Now the question is, does assert work? Because there might be something else screwing up assert as well. Let's see. It should assert no matter what. I am so happy that we have fixed this long-standing problem. See, all you have to do to make assert work is look up the spec for a file format and type in a ton of definitions. And then you can assert. That is how software works, right? You can't assert unless you do that. Computers. told people to fix that like 2 years ago, and they just didn't. They just didn't think it was important, despite the fact that I was saying it was very important. All right. So now we can go back to actually working on our actual problem, which probably still will assert. Yeah, there we go. So the problem now is there's a piece of code. Okay, we sort of factor our global data into two segments right now. Our writable global data goes into two segments, classically, right? There's the BSS segment, which is just everything that starts out 0, because you don't have to store that stuff in the object file, right? And then there's the writable data segment, which is things that are not necessarily all 0. And there's a function that says, hey, does this thing have non-zero initialization data? And if so, put it in the writable data segment instead of BSS. And this thing that we are doing should be non-zero, but it is not being detected as such. So we have to go hit that. Fix assert get desert. That is true. That is true. I need to work out more so that I can start eating desserts again, like really big, nice desserts. We could have fine dessert streams. Wouldn't that be good? Yeah, I could have more chai streams if I work out more too. All right, I've got a brand new tea. If the tea oversteeps, that's a disaster. Is there an actual Donald Trump channel on Twitch? That we could raid Donald Trump. That would be pretty great. I wonder how good Donald Trump is at PUBG. All I can say is don't be living in a major city in November. That's all I can say about that. All right, so this flag is called something like has non-zero init data, right? So a lot of places will be testing it, but okay, we set it on array literals no matter what, even if the array happens to be all 0. So we can set that when we create the literal, and hopefully that'll help. However, this is maybe not the only place that makes it. So we could call this, we could say make pointer literal PL global symbol binary and pointer. All right. Something like that. I might have screwed that up too, but something like that. I'm just looking for other places that make. Okay, this is a null pointer, so we shouldn't set that flag. That's our make pointer literal. So we're doing that, and the location source is ident, and the type is type def pointer to U8. So we need that. There we go. Okay. Who else? Let me see if anyone just says equals literal pointer. There. Uh-oh, I forgot about the tea. Oh gosh, let's pour it. Yeah, these are parts of the executable to be written out, except of course in the case of the BSS segment, the whole point is that you don't write any data for it, right? You just say, here's how big the BSS section is. And then of course, here's the symbol table for that section that says what offset all the symbols are within that section. Okay, this is the thing that converts a string literal into a pointer to U8 for C compatibility. And I don't want to refactor this right now because like this belongs to a different frickin' object because I haven't DC++ized all this. Let's just say, whoops, it's not even the right place. Let's put this in a no check-in because I want to do this before I check in. So all right. Really? That did not help. So we check the declaration's internal flags. Well, let's just check. Maybe somehow I missed that flag on the literal. Whoops. Wait, why didn't... Dude, assert still... Now assert is just like half broken. Like we're getting the assertion, but it's not stopping there. Dude, I'm gonna baby rage right now. So the declaration is obviously not getting flagged. Okay, why not? Wait. Guys, I'm stupid. It is true that I needed to do that flagging that I just did. But that, see, I got confused about this code. Here, this is the section number that the target declaration is in. That's fine if that's in BSS. Like, that's okay. So I got confused when I was like, oh, this shouldn't be in BSS. It totally can be. Whoops. There we go. Okay, so it still doesn't actually work. I don't think. Let's see. Let's see what it is. Do we have anything in there? Do we have garbage data? Do we have double patch? That happens sometimes. We're going to go to our little program here, and we're just going to print the addresses. What is it called? Oh, this long name. That thing. Interesting. Wait, it worked then. How can we make sure it worked? By oh, guys, see here, I poked the value in this line, and then I printed out the value to make sure that it was stored correctly by its other alias, right? Does that look like how to succeed in the game industry to you? Is that how you succeed in the game industry? All right. Hey, look, it's 42, like I wanted it to be. And also, the assert never went off. That should have been a clue that my print didn't match. All right. Oh, that was for the other version. Okay, so this is good, though. This actually works. And so the reason we know it works is these two things are the same. And this is a compile time constant, and this is like a runtime global value. And now we can go back to here, and we could actually just not do this. right? And that should break it. Yeah. See? Garbage value. Because, right? But then we turn this back on and better. Much better. Okay. This is good. Unfortunately, it's only like a quarter of what we frickin' have to do, but we did have a big derail for that elf thing. Let me just rename this for a second. So we don't have to do that. Okay, so that was global symbol. All right. We have to do this one. Actually, wait. Why are we using this one and not that? Oh, that's only for literals. This is only for literals. Let's make that one happen. So we're going to say so that's an array literal, and then let's even make that constant, and then we'll say there. Okay, incomplete data pointer, right? So that's that thing that we put in a while ago. Great. So we have to make that work. And actually, we need to do it for an array. Actually, okay, this is confusing because I made an array of strings, which is maybe not the best. Let's do this. That's an integer, right? And then we'll make one. Sailor. Okay. So we're just going to make two of these. Whoops. Ha ha. Static type checking for the win. Okay. These are obviously garbage values like the other ones. These are not being handled. And the way you extra know they are not being handled is the compiler is telling us, I'm not handling these. So that's good. What's the reason for using C++ over C? Just because I use C++ all the time. That's all. No real reason. It probably would be a little bit better, honestly, if I had written it in C, just because, like a modern C, just because compile time would be faster. But honestly, I'm not taking it that seriously because eventually the compiler is going to need a whole rewrite not in C or C++, right? That date's far in the future, but I sort of regard the source code as temporary in this way. LLVM has a C API. Yeah, I was advised not to use the C API because it is more buggy and less complete than the C++ API. I don't know how accurate that advice is, but I got that advice from several places. I do think the LLVM C++ API is pretty miserable, and it's probably better not to use it if you could help it. Okay. So we have to make this work. This maybe shouldn't be too hard. So we want to do this, except we'll use a different field, even though it's not really that necessary. Pointer literal info. String or array literal. Oh. Okay, so if it's a string literal, we already sort of do this in another place, I think. Oh, right, but what's in x64? Assign. So when we're in runtime code, hey, we look at the literal and then we do this. So let's do that. We assert the offset is not -1 because it really should be handled. And then we say, okay, symbol index equals section number r data -1. That's read-only data. We happen to know what this says is, so the string literal has a count and a data pointer and then the actual data. And what this says is we happen to know this is how it's always stored in the R data segment. So we're adding this offset, right? Okay. We're going to set the add-end there. What is add-end unsigned somehow? I want to make sure that's not true. Where is it defined? S64. Great. And we have to do this garbage. I'm going to be so Marie Kondo happy to clean that up, let me tell you. But I want to finish this other functionality first. Where's it? Offset. Undeclared identifier. Because I changed it in one place and not the other. All right. Okay. It doesn't like that it's -1 by the time we got here. Do I need to call something on it to make sure? Is this, oh, this is the same loop that does, right, this is, ugh, okay. So the problem is, this thing might be before the actual literal in the loop that handles this situation, in which case we actually need to buffer it. Because we assign the address of the literal when we write it out. Although, wait. No, this is wrong because what's really happening is we didn't add it to something else. Okay, this was supposed to have happened on any string literal that we might encounter. And that's at line 955, and this is at line 1083. So why is it not done? The only explanation is that thing is not in the thing. Wait, okay. So also this is confusing because we have a thing. We have a thing out here called literal, and then we're making a thing in here called literal, which is not good. That said, even if you rename it, that actually maybe is more fragile because then you might use the wrong one. But okay. String literal offset into our data segment. So I'm going to assert interp global data string literals that find subliteral, right? That had better be in that array. I feel like that's going to go off. No, it didn't. Oh, yes, it did. Okay. It's just, we said incomplete for the other thing. This is not the thing that we're working on. We're working on the other thing. So yeah. That's pretty weird. Where do these get added? In emit literal. That's only for code. What about global data? Which is what we want. We do string literals sometimes there. Right? Literal string. Copy to global data. Of that string. You know, the problem is that, like, nobody else used that string literal, I guess, because it was in a constant declaration. So like if I say like that might actually fix it. I mean, not really fix, but hey, look, we compiled. And we have a reasonable looking address for this thing. So the problem is just we need to fix things. Now, this is annoying. This is annoying because this code is being sloppy about. I just want to like factor this out and then call it in case we make a pointer literal to the other literal. The problem is this is going into the writable data segment always, but that's like a thing that we're going to want to clean up separately. It's just actually, no, we don't want to do this. So I'm getting confused. No, we don't actually want to do this. I think we do just want to do this. I don't know. Okay, let's go take this back out. I don't know what we're doing for array literals in that respect, if anything. Really? Wait, did I put this in the wrong place? Yeah, okay, this is not right. Okay. There we go. Whoops. That was very autistic. Okay. Hey, it works. I mean, we can verify that it works by saying I don't know. We can print out the ASCII value of the thing. And that 72 and 101, which is going to be capital H, right? 65 is A, right? So that should be 65 plus 7, which it is. And then 97 is lowercase a. So E is that plus 4, which it is. Remember your ASCII, folks. That's H and E in Hello Sailor, by the way. Okay. So that's good. We are not handling this case yet. And this one I'm a little bit slightly worried about. Because I'm realizing, like, how do we even handle that? Like for strings, like when you refer to a string in code, we have an instruction that says, like, here's the string literal. And that does all this, like adding it to the table and making sure it ends up in the read-only data segment and all that stuff. How do array literals? They probably are not in the read-only data segment right now, right? They probably are in in general data, because, and there's no reason to change that because I want to change, broadly speaking, how all that works. How's it going, everybody? So, let's just look in the back end, that's a string, right? There's no array handling there. Like we just literally never do it. So we let it live in the data segment here. Wait, this is when we see an array literal in code. It's real old. Real old. I didn't write this comment. Or maybe I did. Doesn't look like mine though. Although, I think I did and just failed to capitalize. All right. Allocate and copy array literal into global data. So we just do that directly here and set the base address, which is different from how we do it for strings. And again, this should get all refactored. I'm not that worried about it yet. We'll put a thread safety note here. Okay. So we do the same thing now then in here. But wait, where was it? Oh, it was in global data. I'm getting hungry. Okay. This is where we put the patch. It was down here. Okay, subliteral. I'm not going to worry about this paste because, like I said, a refactor is in the near future. I actually tried to do this refactor like a month ago and got busy and gave up on it, but yeah. We're going to say like that should really be inside a read-only data segment, and it isn't right now. It's in a writable data segment. And the reason I'm not changing it right now is because it's a pain in the butt where the read-only data segment is kind of managed only by the back end, and the writable data segment is managed by the front end. And that's just not good. Like what we really want is for the front end to have an array of segments and be able to put things wherever it wants, right? So that's what the redesign is going to be. It's not that way right now. And while I'm in the middle of doing these features, I don't want to try to do that. See, I noticed this. Oh, well, back in 2016, I was like, oh, they're not going into BSS, but like, also they're going into writable data, which is crap if it's a literal. That's not where literal should go. All right, so, yeah, great. So that still isn't going to patch the pointer because we didn't put code there. So now we will go there. Oops, wrong file. We've got so many files. Here we go. All right, so here we want to do the same thing as we did here. We're going to go So base address, whoops, add end is info base address, and section symbol index is section number. This -1 is another just stupid thing. All right. And then we do this terrible, terrible, terrible. But again, yeah, we're in the data section for this as well. And maybe that's it. Oh, wait. No, we have to do a thing. Oh no, because we don't store. Yeah, that should be fine. We don't store a header for array literals. Info base address is greater than or equal to 0. Okay. This, I used the wrong literal. I used the wrong literal. All right. Bytes is equal to, really, copy array literal to global data is unhappy, really? That's interesting. All right, but check it out. Assert actually stopped the program. What's bytes? 8? Oh, we passed bytes. What? What? Oh, we just see we copy and paste killed ourselves here. That was not, we got like a random variable. All right. I think I didn't copy the part that assigns it back. No, because this doesn't care. This is very strange. Maybe I'm using the wrong literal in the other place. Subliteral. Oh, it's called string literal offset. That's the wrong value. That's another paste problem. We want values dot array literal info dot base address. All right. In fact, we did that. Wait, we used the right thing here. So who's asserting? Oh, it's the actual copy. Hold on, what? Wait. Who? Oh, line 1212. Wait, oh. Wait, what? I'm confusing myself. Are we copying this literal? So this particular literal is fine. Or maybe we're using the wrong one. Subliteral. Oh, yeah, look. We didn't do subliteral here. Dang it, dude. Wheels within wheels. Why am I not putting literals in read-only data? Because, so string literals go there right now. Other ones don't. The reason why is just historical. It's just like a refactor that needs to happen. And it's enough of a pain that sometimes I'd rather do other things. Okay, look. It works, man. It works. So the program I'm doing right now is sort of a mix. It's this how-to that sort of tells you what things are constant expressions, right? This is also serving as a checklist, and we're good down to here. Everything here is right. Some of these are supposed to be constant and are not. And that's what I wanted to work toward, checking some of these off. But we had to get the backends working, and we don't even have that because I haven't done this stuff on the LLVM backend. So if I compile this same program with the LLVM backend, it's just asserting like it was before. So we have to do the stuff that we did over there. Hopefully that'll go faster, although who the frick knows, because I don't know LLVM very well. That could be painful. But so in a compiler like this, if you're going to have pointer references in the program, right, there's multiple different places that they could be. And two of the major ones are, maybe you're using this value in code, and maybe you're using it in the global data, and often those will be handled differently. Because you don't want to force something to be in global data just for you to refer to it from code. So although maybe that's fine sometimes. So it is what it is. If you're going to write the code, just even taking integers, right? The code for a declaration int x equals 7, that's in a procedure is just different from a global data declaration that says int x equals 7, right? Those are two different things. And you kind of have to do that for everything. And so prior to the stream, I had these pointer literals working in code, but not in global data. And so now we have them working in global data for the x64 backend. We do not have them working in global data for LLVM. But when we have that, then we could check in after we deal with our no check-ins, of course. And then we can go attacking some of these other things, which actually should be easy. Like these global variable addresses, in principle, most of the work for those is the work that we're doing right now. And then once this is done, those just fall into place, although we will see. What is the difference between a pointer and a pointer literal? Well, I don't want to say the full story about pointer literals because it's complicated and it's also part of the vast power that we will be unlocking. People were asking what was the feature that I was tweeting about. It has something to do with pointer literals, which I'm not going to say what. But when you say the number 7 in a program, that's a literal, right? You can do things with that at compile time, because you just know it's a 7, right? Usually pointers in programming languages are not constants in that way, except with the exception of the null pointer, right? That's usually a constant. But it actually makes sense if you get serious about constant expression evaluation. It makes sense to have a serious notion of a pointer that's constant at compile time. This came up in some discussion. So for example, right, if you have some integer, right, like global int here, right? What's the address of global int? Well, I mean, it's something, and it's something that's known at compile time effectively. Now, it gets a little bit weird because you don't actually know the number for it, right? Because the number for it is like chosen by the linker and or the loader and or whatever. But it's constant in the sense that it gets patched the same way any function pointer gets patched or anything, right? So if you consider a function pointer to be constant, which you totally can, this is the same thing, right? And so representing that officially gives you more power, if that makes sense. And so we're kind of in the process of just doing that. And then we'll explain later. The superpowers come in later. Like right now, we're laying the groundwork for the superpowers that show up later. But I'm going to warm up another tea. We're going to switch off the super strong tea that I've been drinking down to just a different flavor. If there are any questions, I know I've been just sort of sitting here and muttering and complaining about other people's code and stuff all day. But if you have any questions about what we're on topic questions, you can ask them now while the tea water boils. Does that work with address space randomization? Yes, because if it didn't, you wouldn't ever be able to call a function. It's the same thing. Does a linked list get its pointers patched in some way by bake? Bake is really just for procedure arguments and stuff, but yes, you could handle pointers with baked data if your programming language supported that. You could. Okay, we got a new tea on deck. What are the main differences between using pointer literals and constant valued pointers? What do you mean by constant value pointer? Do you mean like casting an integer to a pointer? If that's what you mean, that's not really, you can't do that for almost anything because you don't, unless you're on an embedded system, you probably don't know the runtime value of anything useful. If you mean something like a const reference in C++, that's not known at compile time. Like a const reference is something that doesn't change at runtime, but it is not known at compile time, right? How's my day been? It's been pretty good. Why do I stream on Twitch? I don't know. I mean, I don't know. Twitch it's like better than YouTube, right? Like at least Twitch won't kick me off for not being like a crazy super woke person. So at least not yet. Who knows? It may get bad. It may yet get bad everywhere on the internet. Twitch is fun though. Like, I like Twitch. Twitch has it's got a good audience. It's got interesting streamers on it. I don't like all the dumb infantilization with the channel points and the tangler bit danglers and whatever. But, you know, we just don't run anything that hooks up to any of that. And so most of it just doesn't affect us. How do I stay productive when I have addictive games like Monsters Exhibition begging me to solve puzzles? Well, I mean, I've gone a number of days without playing that game. I played it some last night, but it was a few days. Like, you know. The Rust community has a very signature feel. Yeah, I mean, you know what? If people get all entitled around this language once it releases, I'll just expel myself from that community. And then at least people will know if they don't feel accepted by that community that they have company. And I will do it publicly, and I will make it known that I do not endorse that community. Will this ultimate power feature be shown off in the next compiler demo? No, I mean, I'm not really doing compiler demos anymore. I'm sort of on strike in the Atlas Shrugged sense when it comes to compiler demos. So we're just, whenever I stream compiler work, it's just me chilling. I don't really, you know, I know a lot of people like the demos, right? And that's a reason to do them. But when they just result in exploitation and bad outcomes for other reasons, then there's no reason to do them. What bad outcomes? Just, you know, there's a number of people who do programming language stuff who either, you know, like, who are competing in some sense of like also trying to make a programming language. And, you know, when I show very cool experimental stuff that I'm working on that is years from maturity, right? Often people will take that and do like a crappy version of it that it is not worth doing and that doesn't have the whole good thing about the full version, right? But then they market their language as having this thing. And it's like, you know, so first of all, I give people ammo to compete, but to compete with something that is subpar, right? But then secondly, it just adds to all the noise in the internet, right? The reason I'm doing this project the way that I'm doing it is I'm not just putting the very first thing that I'm able to put out like on the internet with my name on it because I want to poop something out with my name on it, right? I'm working very hard to make the highest quality thing with the fewest bugs that does the most competent job that I can at addressing this certain kind of programming, right? Because I don't want to pollute the internet with any more bad code than it already has, right? And so when people use the demos to turn around and do what I'm trying not to do, right, that again is self-defeating for me, right? Like I help them do that. Now a lot of these people will do this themselves anyway. Like they don't need to be influenced by any of the ideas that I put out there, but like why help them, right? Why help them do the bad thing that they're doing? So that's all. Has writing a programming language changed me? I mean, so anything that you do seriously for years will change you, yes. And this is no exception. Okay. Let me close some of these windows. I actually don't know which of these might have other stuff. Nope, we don't need those. We don't need these. Okay. So I need to go to the LLVM backend and do the same stuff that we've been doing, but it should be a lot less confusing and easier because we've laid the groundwork already. Right? So, well, here, whoops, it's an obj writer. So here's where we added our, these are the two things that we added was global symbol and string or array literal data pointer. God, I really, this thing is just copies of this junk is just pasting out over and over again. It needs to get handled. But we don't have to worry about that for the LLVM backend because it doesn't do things that way. Okay, so I should have a thing that handles pointer literals. And right now, oh, that's a pretty print. Here we go. Okay, let's just do that. So we need oh wait, no. This is not right. This is just for debugging. Do we not do this at all? How else would I find this? create patched data segment. Okay, so for every patch, we do get segment patch value. And then I don't know. So I'm going to assume it's in here somewhere. I didn't write most of this code that we're looking at, so I'm not very familiar with it. Okay. Okay, so this is basically a mirror of what we were doing before. Okay, if it's a pointer, then we can just, I'm just going to make sure that we're in the right place and that this code is being hit, right? And all of these things. All right, so we're going to go here, and we're going to have another error. This is, we're just going to say internal compiler error. And here we're going to go report info literal incomplete unhandled data pointer, just like we did last time. Unhandled global symbol, all right? There we go. Just making sure that these actually happen. And oh, right. Well, let's get this. Do that, and we'll do okay, I guess that's enough. Interp. All right. I expected to at least output some of this. Create patch data segment. Get offset. Oh, wait, what? Hold on, where? We were in get segment patch value. Just down here. What is get offset? Wait, what? So this offset, Okay, something is going on that I don't understand, and it's not documented. Okay, wait, what is going on? We're in line 1414. Star Wars 1414. Okay, so the deal is get offset wants something for every single kind of thing. Like why this code is the way it is. This whole function doesn't do anything. This whole function doesn't do anything, as far as I can tell. It just adds more implementation complexity because I have to like maybe this used to do something and then the code was slowly changed and now it doesn't do anything. I had a note here before. This is from me. I don't know when I made this note, but I said WTF is going on here. Like, this is just, look. We're just taking off and nuking the site from orbit, right? This doesn't do anything. All right. May have made sense once upon a time. Okay, that is what I expected. Now, we have unhandled situations, which we should. Global symbol is probably the easiest one. I don't really know how to find. So what I need to do is find however we take the address of things, I guess. What? Oh, right. So I want to go into bytecode. And we want to look at the implementation of data plus big constant, probably. Or BSS plus big constant, right? Okay, so they're going get element pointer from global database or BSS base. And then the offset. So that's really, hopefully I can use that in a global data context. So if I go back here, so we get the section number. All right. All right. Okay, so What is this called? Generic expression pointer. And then we do that. And then we're going to do these things. And then we're going to say, we're just going to return these because I don't know what frickin' type these are. So we're in LLVM spam land now. Okay, so global database. I don't know what any of this means. We do want to cast it. What does get element pointer return? What? Oh, God. I don't want element pointer inst. I want get element pointer. Oh my God. Get element pointer. I guess it's this one. Like, what? Like, oh wait, it's called get element pointer. What the hell? Oh my God, the page scrolling is dodging me. Get element get element. Dude, my web browser can't even. It says 0 of 1 and then I can't go to it. Why? It says 1. World Wide Web. It's as big as the world. Usually you get element pointer on a global if it's an array and you want a pointer. That is basically, so I just want the address of a global. Now, however, right, these globals are not stored, like LLVM does not get to choose the memory layout, so we're not making an object per global. We're giving it a memory array, and that memory array is like an array of I64s, right? So all I'm saying is like get element pointer into that array, right? Oh wait, it's actually an array of bytes, I guess. I guess this is the base value. I don't know how GEP works. This is the base value. This is the offset value. So this is just, you know, the memory location inside this big array where this global is located. I just want to know what type this is. You know what? I don't even need to know that. Well, except I do. I want to declare it outside here, assign it in each of these, and then I want to say return casted, and casted is going to be, because you have to cast everything all the time in LLVM. And then something get inferred type literal. So like this maps our type to the LLVM type, and this is some function that we have, or this gets the type of the literal. This is something that does the LLVM, get the LLVM type, and then I need to cast to that pointer type after doing this. In this case, get element pointer is returning I64 star, I8 star. No, I want to know what is the type of gap. It ain't I64 star. You know what I mean? Like if I just want to replace auto with something, that's all I want to know. Like what do I type here instead of auto? Yeah. Can I see it in the debugger? Well, I would have to successfully compile the code, which I guess I could do. I was just hoping it would be easier than that. Let's... So here's some random get element pointer, right? LLVM : constant star. I guess. Right? Okay, so then what is my something down there? Get type from defen, right? I think this is an LLVM type. So this is get type from defen, interp helper type definition, and then the rest of that. Type I64, yeah, that's... Is it helper type I64 or just... No? What is it called? Wait, I just copied this from like 5 lines up. Okay. Like what? I'm just gonna do that. I understand why that's that way. It's because it used to be a longer thing, and then we put it on helper and did a search and replace. Okay, the BC, right. This is because I pasted it. So this is no longer what we want. We want... let's call it base. All your base are belong to us. So what's great is these two giant lines are the same except for this parameter. Which I could do that. I could, let's do that. Constant star. All right. Let's do it this way. This is better. I was just going to assume that it was too much friction to do that, but we're just going to do this. We're going to auto that. we're going to put segment here. That's better. Okay, so we do the gep. We do the cast. Dude, the LLVM backend would run twice as fast if we didn't have to put useless casts everywhere. It's crazy. All right, so that was global symbol. Maybe it'll work. Nope. Get element pointer is very unhappy. Let's just say I'm assuming that's even the right thing. Let's see. Yeah, we're using deco base address there. I don't know if my assert would go off, so I don't know why I bothered to put that in. It probably doesn't. Let's just see if we even get a thing. We are not running with the same arguments, are we? Base address 72. Segment is not initialized. What? What? Did you just not do that? What? Okay, so this, I'm jumping to conclusions right now, but this looks to me like a fundamental flaw in what the LLVM backend is doing. Like it didn't, like, we'll see. We'll see. I don't really know why BSS base is uninitialized. I'm a little confused about all of this, but like what? Was? Because if it's not initialized, you can't. I mean, like it looks like it's getting set right there. So maybe it's just a bug. The reason I said fundamental flaw was, wait, no, yeah, like what? Okay, this is silly because until you do this, nobody can point into BSS. So how are you going to... Wait, why are we pointing into BSS right now? This might be a different bug. Oh, because this is... I think it's fine if I just swap the order lazily because nothing can point out of BSS because it's all 0. It's just, this is a little skeezy. Like this... I'm still worried about that. same thing. Create patch data segment. Okay, so this is not assigning that variable. It's making it wait, global database. Do we just never set this? We just literally never set this in the LLVM backend. Am I taking crazy pills? No, we set it there under get global variable. All right. So this is a whole thing where if we're doing threaded compilation, right, one of the helpers, I guess, is in charge of making the variables and the other ones are in charge of just getting references to it, right? Because you don't want to make multiple copies of these things. This is just the way that it was chosen to interoperate with the LLVM API. And the one that gets references to it is initializing, but the one that creates it is not. Right, so this part is, and this part is not. So I'm just going to do it just like it goes below. Is it called that? I don't know. This is called BSS base. All right, so that's pretty weird. I guess nobody ever really tried to do that, though. It seems to me that somebody would, though. Like, I'm really confused by why that wasn't a problem. Cannot convert from LLVM constant to LLVM global. Are these different types? What? Why are these different types? Does that matter? Now I'm going to change this and like there's going to be a billion compile errors because like what? I don't know why these aren't all constant. All right, let's just try this. Like this is the kind of thing I would rather do in isolation with a fully working compiler so I can see. Because sometimes I change some things in LLVM that I think should be equivalent and they're just not. Oh, well. Well, that was interesting. Okay. I think maybe that worked. Right, it did. Look, it did because we got a 42. Right, and the way that we get the 42 is by poking it into constant pointer stored globally is non-constant, right? And that is this thing, which is what we were just doing. So congratulations us. Now we just need to make these work. Data pointer. So that was the actually. Oh, I guess we do the same thing there. Okay. Anyway, after all this works, I want to uncomment this version because this one looks the same as these. It's actually not the same because these are literals, right? And this is, mutable data, global data, right? Which is why this gets a different pathway than these, but they like look sort of the same. So I want to make sure it works with this, which doesn't look like that. Global variable is a subclass of constant. All right. Well, fortunately, it didn't seem to break. What kind of workload is a junior developer expected to perform? Even what junior developer means it's basically random, depending on where you're at. Who knows? Okay. How's it going, everybody? We're having a good day, mostly. Any day when I have to deal with LLVM is automatically not the best day, but if I don't get stuck in a giant swamp, then it's maybe not so bad. So we have to do the other... This one, the unhandled data pointer, right? So now when we compile, we get these. So all we need to do is something similar to what we did. String or array literal, and we probably have to do something different for each of those, right? So let's go back over here. Whoops, I keep going to the wrong file. Always do. So we get that expression, which we've already got, and we get the subliteral, and we're going to do different things if it's a string or an array, or we report an error. Okay, and then I'm just going to jam these in here for now. We're just going to make sure we compile. Real easy. Real easy. Now in our compile case, this one is an array and this one is a string. So we've got both of these pathways that we're working on covered. Okay. If it's a string, and then what do we do with this? We say probably the same thing. This giant ass gap here. Oh, and we do all this because I did this the other day. So assigning to the strings. So this gets the string. Oh, you know what? We have the string data offset anyway. All right, so so we just need to do all this stuff. And I kind of would want a function to do all this. It's just, like, because I don't just want to keep pasting code all over the place. Let's see. So cast ns is what? Do I have to be running to see this? Cast ns is, what's the type? How do I know? Why does it tell me different things? I just want to know the type of this. It was very easy to find that out before. How do I know the type of this thing? LVM value star, someone says. All right. So kind of what I want to do is refactor all this stuff. This thing is basically saying, hey, do you want the base of the string literal or do you want the data pointer? And our other side always wants the data pointer, right? All right. First, let me just refactor this in place. So we're going to say result, all right? And here we're going to say, see how I kind of have this create store with all this? We're just going to say, oh, not auto. We're just going to say result equals this, right? I hope create load is also the same thing. And then we're just going to put the store down here, right? And we're going to do that. And then, of course, we could put all this stuff into a function. Okay. Whoops. It's lowercase. I'm getting hungry. I want a giant pizza because I've been a good person today and done lots of work. But I don't want to call Uber Eats because I have miserable experiences with them. I mean, this wouldn't all work if we just screwed that up, right? Right. Okay. So that must have worked. So now we're going to say result equals get string literal base or data pointer. We need the helper, we need the literal, and we need whether we want the data pointer. Boom. Okay, where do I put this? Who knows? I'm just going to put it there because I honestly don't care. So LVM value star get string literal base, right? What is helper? LVM helper. Helper ask literal bool bool want data pointer. Okay, we fire the gep gun from Deus Ex, and if want data pointer, and we could just put returns in there, but we'll just do this because why not? Okay, this is not good. We need the target type, result type. I honestly don't understand Okay. So this is a very weird thing. I feel like there's something wrong elsewhere. Like this is just saying this register is just our bytecode register, right? It's not like a machine register, and it's not anything in LLVM. And, you know, but we create an LLVM, you know, type for that. And we say, you know, cast to the type of the thing and then load. But here I had to do this weird thing to make it, I don't know. Like what? That just seems wrong to me. Because of the load, one has an extra pointer level. But it's the opposite. Right? Like I'm casting this and then loading from that. Does the load add a pointer level? Is that what you're saying? I don't understand what create load does, I guess, but get pointer element type is removing a pointer level. I see. So this is like whatever. That doesn't seem right to me. Like, okay. Okay, I guess that makes sense. This is like whatever the result is a pointer to, we put. I don't know how this was set up. It's inconsistent because either way. No, maybe it's not inconsistent. All right. All right. I'm just going to try doing this. Type. I don't know. I kind of want to stay away from LLVM data structures, but I just feel like maybe whatever is happening here is a little bit compensating for something that's weird, and it'll break when I try to do it. Basically, I feel like most programmers right now, where I don't really know what's going on, and I'm just kind of dealing with the fact that I don't really know what's going on. What is IR builder? Do I need to pass this? It's like a temp. What? Do I need to actually pass a weird garbage template type? Hold on. Is that passed in here, or is it? Where does this come from? IR builder. Yeah. Oh my God, dude. All right. RIP. Wait. Does IR builder... If I use IR builder... Is that only for code? Like, does that mean that I can't do global data? Do I need to use something else and do like constant expression casts or something? Because the whole reason I'm factoring this is so that I can call it from global data. If you're moving a value, you probably load storing it, which has some time constant whatever. Constants use other things. Okay, so after this works, I need to rewrite it. Because all of this, I mean, I could use the constant versions in code, right? Or can I not? Like all this, so like where's the stuff that we were just doing? Like this kind of constant expert get element pointer, right? Can I do that in code? As long as it's operating on constant things, right? Constant expressions are global and unique to a module. Right. Right. So constant expressions I could use anywhere in code, in data, or anything. But this IR builder stuff is only code, right? Right. That's what would make sense to me. So like I kind of don't want. So the problem is, I need to figure out how to do this create load, which was stupid in the first place. Oh, no, it's right. It's just plus this, because we know it's a literal. Yeah. Okay, great. So let's make sure this still runs, and then I'm going to have to change it anyway. Like, that's great. I'm assuming that pretty much none of this would run, because like these print statements are using string literals, you know, for like the print function. So pretty sure that's going through here. Like if I do this, right, that's just going to destroy, actually, I actually don't know if that's going to, because that's just for the C style. Yeah, that actually won't. It's this one that's usually being used. One of the features of some IR builders is that if you try to create a constable instruction, it'll create a constant expression and return that instead. Yes, but does it do that in a compiled time way? Like I actually don't want to have to pass an IR builder, you know what I mean? Because in this part, the part that we're trying to get to, which is here, which is when we are doing global data segment patch stuff, like there's just not an IR builder here, you know? And so making that a parameter of the function is terrible. Okay, so really what I want to do is actually so before I forgot about this thing, I guess, when I wrote this the other day. Here I'm saying, hey, we want to get the data pointer out of a string literal. Do we always know? Yeah. And we're doing that by going to the place where the pointer is and then reading it. But we know, again, how this is, or do we? On LLVM, we don't. That's the, oh my God, dude. In the LLVM backend, we don't know that it's stored contiguously. And that's one of the rewrites that I want to do eventually. Like, but we're letting the backends pack this string table, I think. And that's why I'm doing this read. What a pain in the butt. So I guess I need to store when this literal, let's just see. Where does this get set? Yeah, see, this is just like an integer. And like, what? So here we create the string in LLVM. And then we make a string array. And so that thing, that value that we're using is actually the index into the string array, I guess. Maybe? Because how else would you find... it? Right, so this is the actual string struct, which is, you know, integer and pointer, and then we add that to this string array. We get an array of all the strings, but we're not actually, oh, string var. I see. So this is actually the C style string. I need to actually get it that. It would assert if I accidentally try to create an instruction. I mean, I kind of want to fix this anyway. Because this, if I don't fix this, it will create an instruction. Let me put it that way. Like, it's going to create a load here if I don't get rid of that. And also, this is just generating extra badness that has to get optimized out. It's scary. I kind of want to run this on all the test cases now, except they won't work until we finish what we're doing. Okay. Anyway, so we're getting this string var, and that's getting put in this constant struct. So we could like dereference the constant struct if somebody can tell me how the hell to do that. Or I could just make a separate array because... No, because then I have to... I have to like cast the elements. So this is the empty string. This is so precarious. So as far as I can tell, like it's semi-accidental that this offset is equal to this index in the array, and like nothing is frickin' asserting that. So that's like gonna break as soon as somebody sneezes. Nobody else uses string array. It's just used locally to create these things. All right, well, yeah, I need to I'm just gonna put this on the literal for now. I mean, this is freaking disgusting. No, I'm not going to do that. I'm not going to stoop to that. What I'm going to do here is I'm going to have a thing called string Oh, there is an assert here. Okay. So it could break, but at least we would have an assert, except asserts don't do anything in this file, so we won't have an assert. Like, all right. No, you know what? I should. Okay. No. No, we're just going to have the values. String data array. Oh, wait. String data array dot add of string var. All right. So get or create string that is a constant star. Great. We're just going to make this local for a second so that we make sure this works. And then we're going to put it somewhere where we can get at it. And I don't exactly know how to share this data at all. Okay, so that's running still. So now I need to get this array, instead of being local, I guess I put it on the module. Wait, is that an LLVM type? I guess that's an LLVM type, right? Yeah. That's not where we want to put that. We want to put that on the helper. But this is again weird because one of these has the authoritative array Wait, what? Oh my God. What even is going on? Like, what is global strings? Are you fucking shitting me? Okay, anyway, yeah, I'm not going to worry too much about this stuff. Yeah, so these are basically the function that I'm writing. I want it to either give a constant value for the base of the string struct or a constant value for the data field, right, which is the C style zero terminated thing. So like I said, I'm not gonna worry that much about this, a lot of these string things, because this is all gonna get burned with fire eventually anyway, because we want the front end to pack the string data segment. Like, we don't want that to vary with backend, right? That's something that I should have structured it that way a long time ago and just didn't do it that way. So I want that to happen, but I want to finish this first is my problem. Because I don't want to, that's a giant change and I don't want to do that. So I'm just going to make this data structure. And the problem I have is, like, there's just multiple helpers, and like, where do I even... Like, this says global strings, but it's local to the helper. And those are... This is a thing where if I had written this code, I would just know what to do, right? And here I don't. So there's like primary module setup, which I guess is the first helper. Right? Like, okay, we declare a helper as a local variable. Okay, if the ID is 0, it's the first one. And here we make references to other things. This just isn't really how this should be structured, honestly. Like, the thing that is... The thing that contains all the values that everybody else refers to should just be a different type. Like I've done things this way before and it just gets confusing and bad. And like, because right now I want to store some data. Like this was in primary module setup, right? That's why I even knew that this was a thing. Yeah. So like I want this string array to be on one of these and pointed to by the other ones, unless they have a pointer to the helper. So like, yeah. So like the deduplicate that's even happening is like, why is that global strings different from that? Like you're gonna do all the strings twice accidentally. Oh my God. All right. I'm not even gonna worry about that. More than probably like 4 times. No, just twice. Okay. You know, can I just put this on like, is there like an LLVM converter class or something? What's at the top of here? Nope. All right, garbage code it is. Maybe I should just make it a... Are there file level globals? No. There's just no way to do this that I could tell. Sure have a lot of libraries though. Anyone want a library? All right. So this is now gonna be okay, string data array. So doing all of that, hopefully that'll compile. Not even using that yet, but did I talk about the super awesome secret feature? I said very vague things about it on the stream. Yeah. Okay, so we're still running. That's great. So now I want to actually use this. Okay. So we're actually gonna break this up again. Simply because we're not even gonna actually in this one string data equals helper arrow, what was it called? String data array sub and actually we don't even need the cast, I bet. And we don't want to create the load. I think we just want this. Let's do this. That's index and that's index. Cannot convert from constant to value at 338. Right. Okay, but we should just be able to make this be a constant, right? I don't know what's on the calling side of that. Cannot convert from... Oh. Oh no, wait, what? How did I goof on this? Oh. Yeah, so it's just the subscript. Because it's a pointer to an array, I was subscripting the pointer. Okay, so 343. So create bit cast from IR builder. So we need like constant expert : : right? Get bitcast. It's not create bitcast. All right. Totally crashed. But at least in a way that we can maybe diagnose. All right. So, well, wait, what? Okay. So we're indexing off the thing. No, we never, I forgot the part where we copy it. So we did the part, so in this primary module setup, right? We do that. But here, how do I know what the 0th helper is? Oh, I don't. Okay, I have to make it a file level global because these are like function scope. Like there's literally no way to do what I was trying to do. All right. All right. Just the moral of the story is I should never work on code that wasn't written by me. That's all that I can say. Okay, so this at least goes away. Okay. Like, do we even know that this is completed? Whatever. I'm just going to hope. Just going to hope against hope. All right. Well, now we have this common thing that happens where LLVM makes this impossible to debug by like auto naming things, and it doesn't tell us when it does that. So like this is hours to debug this right here because LLVM hates everybody. Oh my God. Oh no, it's not a double declaration. It's an unresolved. Okay, right. Oh my God. So the problem is I'm using these variables. Okay, see, normally, ideally, we would be outputting just one object file, right? But because LLVM is really slow, we actually parallelize this. Like if I run this with no jobs, we probably don't have this problem. Maybe I'll do that and I'll make it work with jobs. Well, we have a different problem. Dude, all I'm trying to do is so simple. It's like 2 lines of code and it's going to be hours by the time I'm done. So the problem is because LLVM is so slow, we like process on multiple threads and then save out the object files, I guess, because there's no other way to link those together, right? And now the problem is the object files need to refer to each other if they want to use frickin' strings that are in those different files. So like, and this doesn't seem to be commented very well in this code, but it's like, I guess that's why they were duplicating strings in the helper before, because you didn't have to worry about this. Because otherwise I have to like make symbols. I have to make like global names for these strings and then like link them across the object files. What a disaster. Maybe I'm going to dereference the struct. I didn't want to do that because that was a pain, but it might be the least painful pain. Sue derp to get anything done. You know, I've been there. I've been there. I've been there. Okay, let's try this the other way, which is also going to be very regrettable, but we're going to comment this out because that's not a good idea. Okay, so instead, we have this string literals, and we have an external symbol defined for that. Can I, in LLVM, dereference a constant struct as a constant? I must be able to, right? Although I don't see how that works if it's external linkage for the, because it doesn't have the data there. Like it just can't. I can check the initializer, which doesn't exist if it is external. I don't know what check the initializer means, but it's going to be external. That's the thing is, you know, there's another meta issue going on here, which is just sometimes code or systems or whatever are written in a way that lets you pretty easily do what you're generally going to need to do. And sometimes they're not. And this one really is not. Like it's some combination of maybe LLVM or maybe the way this interface to LLVM is written is like, it makes it very annoying. Like all I want to do is return either the base to the string that we already know or the data pointer of the string that we already know. We know these things. We gave them to LLVM in the first place. They're right there. They're constant. We know what they are. That's all. It's the simplest thing in the universe. And like, I can't do it. Like, this is what web programming is like. The initializer is when you specify the contents of a global variable. Yeah. Yeah, so the thing is, it's not that I need to get it if it happens to be there. It's like I need to get it, period. So maybe you should ask Galactus. What are my options? I can make a single with external linkage for every single string, which is terrible. I can punt this feature. This is what I'm going to do, actually. I'm not going to finish this feature. Okay. I was maybe going to ship the beta. You know, like I was going to do this last constant stuff and ship the beta. We're not going to do that. Because the problem is I need to do this. And like I said, I shouldn't be doing any of this because we should just be handing the string table to LLVM and saying, dude, here's the string table, right? We already do all that work for the x64 backend. And in fact, we already know what these strings are like before we even call the backend. So the front end knows what the list of strings is, right? So the real way to solve this is to just factor out the packing of the frickin' string table so that I know the actual addresses of everything, all right? And they're not like handled by LLVM. And then because we know what the addresses are, we can just do this, right? So this part here, that's very simple. I mean, very simple, like for LLVM, right? Everything in LLVM looks giant like this. But this part that's very simple is just because, dude, we know the order that the strings are laid out inside this thing, right? So we can just do this. If we give it the string table, we can do this. We don't have to do any of that string table building code that was happening there. We don't have to worry about any of this being shared among threads and whatever the hell, right? So like I had wanted to just get this feature done before we do that, but I think we're at the point where LLVM is the pain point and the solution is to remove this data from LLVM's purview because there's no reason, like even if we weren't having this problem, it would still be bad to do it this way because it's just more code and more backends and more inconsistency for no reason, and all this stuff. And so I guess we're not. So the problem is, though, I do want to ship a beta to people. So maybe what I have to do is actually turn off this feature in the front end for a little bit. Because we want everything to work on the LLVM backend. So yeah, I just need to turn, it makes me sad, but I need to turn off the feature for a little bit until I can rewrite this. Because this is just, it should be so much simpler than what's going on right now. Now, it's interesting. So this is, again, an aspect of general software engineering, which is the less that you know about what's going on, the harder it is to deal with, right? The more generally you have to be about handling it. So part of what's happening here is like, oh, we don't know what the data is because it's symbols made by another object file and blah, 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 right? But like, there's no reason to have that problem. We just happen to have that problem because we did it that way, right? Whereas in the x64 backend, well, we don't need to parallelize that right now because it's a lot faster, but even if we did parallelize it, we wouldn't have this problem because we know what the data is, right? And the way computer science is taught, one of the things that's bad about it seems to be there's a conflation, right? The thing that is taught is that, hey, you should always program your system to handle the broadest variety of problems, right? Which is good, all other things being equal. I agree with that, right? But all other things are often not equal, right? because the more general the thing is that you're handling, the less you know what's going on. And so it leads you to doing crazier and crazier amounts of complication in order to be general. And here, this is sort of a victim of that. It's like all, you know, it's all very silly. Like, this should be just an array of bytes that we have indices into. That's all it is, right? And that's why I'm so upset about trying to deal with this. So I'm going to back this out a little bit. I'm going to try to repair this to where it works, because we need regular string literals to work. Uh-oh. What was this create load? Is it just that? I don't know how many arguments create load gets. We're just going to do a return here and a return here. I probably got that wrong. Return. Okay. So this whole thing, we're going to go back to value here for now, because we're trying to make this work again. String data array. Oh yeah, this whole thing. That's just going away. Gone, gone, gone. Whoa, whoa, oh. It's just like sometimes the simplest things are just made so, oh my God. I really screwed something up. Like every single symbol is unresolved now. What is happening? I'm gonna cry. I'm gonna cry. The LLVM way to do this is define two private string globals and have LLVM deduplicate them. Yeah, no. No. Especially because if it doesn't happen to do that, it'll mess with our language semantics. We can't do that. And also, it's just tremendously inefficient, right? There's no reason for that. What did I screw up? Okay, we'll keep that. This is our added value thing. We can actually see what that used to be. Get offset, right? We took that out, that was fine. This is all new. I'm scared because I'm not seeing what's wrong. And we're out of differences. Like, wait, what? Okay. What are the chances? The chances are basically 0, but let's just rebuild to make sure it's not a compiler being confused. Unresolved external symbol. Like, all our functions are what? How did I break that? Okay, let's hope it was fixed. Hey, look, it was magically fixed. That was like just a compiler inconsistency. Visual Studio gets things wrong, like timestamps wrong sometimes. Or like it caches data structures and doesn't update. Yeah, that's why I don't like incremental builds. All right, so we're actually in a good spot. I'm a little bit sad that I have to back this down for now, but that's fine because it means I get to do another big thing that I've been wanting to do. Yeah, it's exactly. The solution suited to this language would be to put all the string data itself into one big array and reference offsets into that globally. And we, in fact, already do that in other parts of the code, right? It's just, in fact, we actually do that like, it's kind of bad because all the backend stuff grew organically, but we do that like 3 or 4 different times for different string tables. And so part of what I need to do is just say like, look, here's a string table, or like, here's just a data segment that anybody can use. Like, here's the patch array and whatever. And we sort of have that. Like one of the pieces of code that does this will be the right one to do that with, you know. Okay. So I could turn this off for now, but so as not to derail it, I could work on this is so not good. Like, we're gonna have to do this with array yeah, it's fine. We just have to remove everything but code generation from LLVM's realm of responsibility. Like it shouldn't have anything to say about how data is packed. Not least because we just want that to be consistent anyway. And it'll also just be simpler and more and faster if we do it. So that's fine. All right. So my goal right now is to turn off pointer literals. Even though that's what I've been doing today and yesterday. I want to turn them off because they don't work in global data yet. And I don't want people's code to just arbitrarily break if they happen to try to use pointer literals. And I could try to make them be used except in global data, but like that's probably annoying. So I would rather just turn them off. So all right. Oh no. Dang it, dude. Oh no, guys. I have a problem. I can't just turn off pointer literals because I took out some of the old code that handled this stuff. Okay, wait, I think I can do it. I think I can do it. It's just, if this turns into an ordeal, I'll be very mad at LLVM. Except I'm already very mad at LLVM, so it's fine. think I need to. It's the array literal version that's a problem. Oh, but we have this fallback. Okay. Dude, like the to-do list just gets, like I wanted to wipe through most of these today, and then I hit this, and it's like, I can't do any of these. And so then it just gets longer and longer, and then I die from old age. I guess beta is delayed for a while. No, beta might not be delayed because I want to get some bug fixes to people. It's just, I'll probably ship the beta before this is complete, before this feature is complete, which is a bummer. But you know, it's fine. Like there's good, you know, so you can see, you know, there's some bug fixes and stuff here. I don't think I've actually done that, so. Yeah, there are some significant bugs in here that people had, and I want to ship that out and not delay. You know what I want? I want a nice girlfriend where when I can come home from work, I can tell her all my troubles about how I was going to get tons of stuff done, but LLVM didn't cooperate, and she'll sympathize and bring me a nice cup of hot cocoa and then know miraculously what to go type to fix it. And then it's suddenly fixed and everybody's happy. You know what I mean? That would be great. Don't have that though. In fact, she would just rewrite LLVM that night to be 20 times as fast and 1% code size. And then I would marry her instantly. So, but that's not reality. That is not where I live. So, it is what it is. So I was doing this, and I think that might be enough to turn it off, but I feel like it's not. I feel like there's some stuff in Bytecode Builder. Then I discover she secretly writes JavaScript. Divorce. Divorce. You can't find that in San Francisco? No, you can't find that in San Francisco. Are you kidding? Are you kidding? All right. San Francisco is all dudes. Yeah, you know what? The only thing I really have a problem with right now is the string data fields. So why don't I just turn off that one? I can just make that not be constant, right? So like, these I could enable. It's literally just this one. And I think that'll be fine. Right, so here we have string data field. And so we can just comment that out for now in our test. But we can keep the other ones. Okay, this is actually fine. So we can continue ahead by a different strategy. We're not going to fall back. We're just going to make that one thing not be constant yet. And that then we'll know about that because when we run this, it'll say not constant in this list. And I'll be like, oh, I don't like that that's not constant. Back in LLVM here, I was factoring this string thing into a function here and trying to make it all constant under the assumption that, you know, I was going to try to use it from both places. If string data fields cannot be constant yet, we don't need this at all. We just need these couple of lines, which I'm fine just pasting, right? And then we can ship most of the rest of this feature in the beta. The only thing that won't be constant is string data fields, which I don't think people are going to miss very much until until later. I like this. Okay, we're going to do this. So where the hell were we? We have unhandled data pointer. But don't I need... Oh, wait, that was the whole... Right. No, this is done then, because... Okay. So for the case of string, this can't happen yet. We're going to make this an error. Internal compiler error, incomplete, unhanded string literal data pointer should not be possible to get here since the front end doesn't generate it. Okay, that's fine. This is great. So now we just have to do this one, which this one, the array literal is just in an array of bytes because it's in the writable data segment right now. So we can just frickin' do this one and have a party. That is what we're going to do. That is what we're going to do. Okay. Now, I can just go look at what we did. We're back to trying to actually program now instead of doing damage control. Okay, so here we have the array literal info. The section numbers are not the same. So I'm going to have to figure out how to do that. Okay. Does anyone else look at array lit? We're just going to delete this since that was successful. Nobody else even looks at array literal info. Global database. So we just need to do this, essentially. We need to get segment patch value of, probably we can just call this, wait, that's where we are. We could just call ourself, that's recursion, right? If you don't want to write the code, you start writing the function and then just have it call itself. That's no problem. Yeah, so we're just going to say this is the segment, and then we're going to do this stuff. Right, so we get the element pointer from the base. We cast it to the type, we return it. Seems plausible. That looks like a reasonable address, doesn't it? How do we verify? Well, what was that? Yeah, oh, we didn't want to do that. Okay, so this is so we're going to dereference that. That should be 77, right? Ta-da. Okay, great. We just don't have data field of a constant string is not constant. All right. And I'm putting some incompletes at the bottom. And we're just going to tell people if they run this example, look, data field of a constant string is not currently constant, but it will be. And then this stuff down here is not part of this program. This is more like test stuff that'll break into a separate test case. But this is good, actually. So it just means as long as I ignore this one, we can go do these things. In fact, we should be able to do these two next. But I did a bunch of weird stuff. And so I think I want to run tests in debug mode and check in and all that, and get rid of my no check-ins, of which there are many. Any questions about what's going on? As long as I ignore this one as a way to deal with things. Yeah, it is. I mean, sometimes that's just how you actually, I mean, I'm not ignoring it forever, but it's like, okay, we're just, that one's for the next beta. In the meantime, we're going to ship people the rest of it. You know, that's why it's beta. That's why I can't get a girlfriend who rewrites LLVM overnight, is because she thinks I'm beta because I work on betas. Got to start working on alphas. I know. Why am I releasing betas to people? That doesn't make any sense. Is it a closed beta? Yes. It is an emotionally closed beta. Sure looks like we're passing the tests, which is great, I guess. Uh-oh. Nope. Oh, this was this other... remember? Way back when I was in the middle of other things, and I was like, what's going on here? And it was because of that. This is probably not that hard to debug, although honestly, we're going to find out. We're going to find out. It seemed like a simple thing. Don't even remember what it was now. I keep saying I'm hungry and I keep not doing anything about it. I think we're going to have some baked cinnamon bread or toasted cinnamon bread. Approximately how many people have access to the closed beta? I mean, about 20 people right now. Not counting people in our company, right? How many of those are actively using it? I don't actually know. Not all of them. You know, sometimes people go through phases of using it for a bit and then taking a break and whatever. Do I think the rewrite will also use LLVM? I don't know. That's pretty far in the future, so it's hard to say. Like, I could always see, like, we may always want to use LLVM or something like it if an alternative shows up as a way of targeting new platforms that we don't yet support. That said, maybe there's not much point in that, because maybe it's just not that hard to write an unoptimizing targeted thing for a new I don't know. Anyway, the sort of the default plan is to use LLVM as an optional backend for platforms that we don't yet support optimized backends for. So yeah. Okay. So what is going on here? Binop mod. Why? What is going on? Line 127 of clustered shading. It's a new file. It's possible that this isn't even due to anything I did. It's possible that this is a different compiler bug, because this is a new file that was just checked in yesterday or today. And so maybe I just hadn't built it in debug yet. I don't know. Okay, anyway. So we're doing mod cluster build threads size X. Cluster build threads. I don't know why it says the number flags have... Okay, that is just a compiler bug. This is not a float, right? So this is me screwing something up. I don't know if I like this style of putting these next to each other, but okay. Okay. How much is LLVM actually doing? I mean, it really is doing a lot. Like the problem is writing an optimizing compiler in terms of optimizing code can take an infinite amount of engineering effort. Like it really can be a lot of work. And so that's valuable. That said, I'm pretty sure that like 90% of the effort even that goes into the optimizers that LLVM has is stuff that I don't even want, right? And so it's probably 10% of the work that went into LLVM's optimizers or less for us to have good optimizers that we would be happy with, but that's still a lot of work. Like a huge amount of time has gone into the LLVM stuff. And so it simplifies my life to not worry about that right now, but I do want to do it at some point. Mod 16 is kind of hard, yeah. Mod 16 is an advanced FizzBuzz level functionality. It's the sequel lecture to Secret of Mod of Psalm 46, is Secret of Mod 16. So flags A this is just incorrect. I think that number size is supposed to be in bytes. Maybe not. No, I guess it's in bits. No, this is wrong. This code is wrong. This is a float. So the error is we're just not checking operator mod. We're not checking operator mod for float correctly, because everybody knows that if one of the arguments to mod is float, you have to use fmod, the indie game sound system, and then all the sounds that you play will be played through fmod. Who are the other people working on the compiler? Currently, I am the only person working on the compiler right now. We'll fix that though. Okay. Well, this is missing type check. So, and probably the reason this happens is because it's probably handled at the same time as divide, and I just didn't think of it or something. Like we check that the types match. A lot of stuff happens in this function. Custom operator detection, struct dereference, array subscript. Maybe we break array subscript into its own function. It's just represented as an operator in the syntax tree. Okay. So wait, if I just go to our program that we've been compiling, it looks like I don't test. Like bitwise OR, which, I mean, we might want to support bitwise OR on floats. Whoops. But we don't currently, I'm pretty sure. Yeah, like it's hitting the LLVM backend. LLVM doesn't support that shit. So, yeah, we have to. It's kind of crazy that I could go this many years and not notice that the compiler doesn't check for this, but welcome to compilers. So what out of this list? Yeah, mod and an OR. Floating point values are not supported. Okay. Okay, so we're gonna, so if So we're going to get left flags and right flags. And okay. Does not work on floating point arguments. Left type, whatever. Operator name, left name, right name. We need the operator name as well. Type to string is not even really. Oh, it's interp type to string. Boom. Boom. Okay, so that's great. Fix that the operators mod and whatever did not check whether arguments were floats. What would OR and floats even do? Just bitwise? Yeah, you would just bitwise OR the bits, but I think it's fine to force people to bitcast to integer in order to do that, you know? Because like the floating point unit is not going to do that. That's an integer operation, so. All right. Great. So now we make sure it catches it in the compiler. Are we still debugged? Yeah, we're still debugged. There we go. Operator mod does not work on floating point arguments. Actually, we do make sure the problem is by the time we get here, the type's going to be the same on both sides because we ensure that it is via a cast. Okay. Let's try to provide a little more information. All right. If detected float actually, we'll just do this. All right, and we're going to say %s and extra help. Going to get rid of this period. So it'll put nothing by default. We don't need these. And so if we're just going to do this. Okay, if that's not a cast, if it's not an implicit cast, all right, if it's not an implicit cast, then whatever you wrote in the program made it be float, as opposed to it becoming float to match the other side. You know what I'm saying? So, extra help is actually left argument was a float of type whatever. Interp type to string of left type. All right. Okay. I don't think I have is implicit cast, but yeah, no. All right. So we're going to write that. See how easy it is to write code when it's not in the middle of a giant boondoggle? Is implicit cast of asked expression great. Left argument was a float of type float. I mean, that's a little bit pedantic. Let's just say of type whatever. Right? And then we can test the right argument thing. Okay, because this could be float 64 or who knows what future floating point types. Okay, so now let's go to that file, clustered shading, and let's just put something here. ZZZ is 3 mod 2.6. So that should complain about the right argument. No. Oh, because it won't be a cast if it's a literal. Dang it, bro. With literals, we just harden the literal because it's constant. Dang it, Bobby. Dang it, Bobby. I just want to make a good error message. Okay, we'll make a flag on the frickin' literal. I don't know. Where are my numeric flags? Past. All right. The problem is this isn't a good way to do it either, because these will propagate in a way that we don't like. I think I can actually just check the substitution. Let's see. I have to recompile because I changed something from the header and then unchanged it, but saved it. Bang it, Bobby. All right. So I guess one of these has a substitution that is also a literal. Neither one does. So we literally just we set number cast hardened type. Okay, hold on. We probably set that no matter what. Dude, I don't know how anything in the world works. Apparently. So this one wasn't int, it got converted to float. Oh, we have number cast count. Yeah. Okay. No. This is good. This is good. This is good. I forgot that we track that for operator over for function overloading purposes. I want to say of some kind, because I don't want people to think. Okay, if it's a literal, called cast count. Is it called number cast count? What is it? Number cast count. Right argument was of type float32. And then if I remove that, left argument was of type float. So we have a helpful error message Now let's fix the code. All right. Okay. I guess that's right. Did I typo an X or a Y? X, X, Y, 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 X, 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 Y. Save me, chat, if I typoed. Okay. Is it clusters? Is it that? Did I do that? Apparently so. Hey, look. Game runs. Look how good that game looks. All right. Let's check this in. And then I need to tell the dude who was working on that because, yeah. So I'm going to do that real fast. I'm going to say, all right, I have let him know. Close this because we're not looking at that anymore. Let's close this. So many windows. It's like I'm using Microsoft Windows. There are so many windows. All right. So, let's just do this with release compiler. But I think now we get to build and check in, unless any of the test programs were also making that mistake. So any no check-ins. Oh yeah, there are definitely no check-ins in the whatever. You mean lines of code of the compiler? Let's see. It's probably a little higher than in the past. 52883. I think that that's going to go down a little bit from the string rewrite that I want to do that I was talking about today, but probably not insanely so. And then the game, of course, it's inching up there. It's inching up there. All right. Let's run the tests. How fast does it compile? Well, it depends what you count again. So first of all, we're streaming, so we can't, our cores are a little slower than usual. That was really slow. Hold on. So right now, we're at 1.6 total. About 0.6 of that almost is the linker, right? So we're just over 1 second. If we weren't streaming, we would be significantly under 1 second. But that's a lot slower than it should be also for probably a couple of reasons. One is I just haven't done a performance sweep over the compiler in a long time. So there's probably a bunch of places where it's like looping a lot and not doing a lot of work, where certain kinds of things need to happen. And then two, we have just a ton of static ifs in there for like whether OpenGL is enabled, and it's way more than a reasonable program would have. Although, I don't know. And static ifs on a constant don't have an optimization, so those are a lot more expensive, and that's probably driving the compile time up a little bit. But basically the way it works is I work on other things and it slowly creeps up, and when it gets enough over 1 second, I go and look at it. And I've been wanting to go and look at it and drive it down again, and I just haven't done that. But yeah. And this is actually slower. I thought this would be 1.3. And it's a lot higher than that. So either streaming is more hardcore than usual, or we checked in something that's a lot slower to compile. Things got a lot slower when we added all these WWise modules like that. That drove, like, all of this is just for WWise, actually even more. The AK bridge as well. That just makes the linker take a really long time. Like 0.6 seconds to link. We generate all that stuff in almost 0.9 seconds. So it takes, 2/3 as long to link as it does for us to actually compile. Well, this part of compiling, and then this part is the machine code selection. But even this is taking longer. And last time I looked at it, there was some stuff other people besides me had done to it that I wasn't happy about. And so, I want to do performance passes on all these things again. All right. Are we releasing the game and the compiler at the same time-ish? Probably not. I mean, it's just, I think for each of those, it's going to happen at the right time for that thing, and I don't want to hold up one for the other, I would expect that open beta of the compiler comes before the game, which is a little bit of a bummer in the sense that we won't, like, the thing that's supposed to be cool about the game is that we release a full engine with it, right? And so that won't be available at the initial open beta of the compiler. But, it is what it is. Okay. Now, I guess we ran that and it worked. So now we have to do the no check-ins. I'm just not gonna make this a no check-in. I'm gonna put that in the to-do. And then, okay, well this, we actually implemented that, so that's good. And then this is that thing that we got rid of, so that is fine. We'll just run it again to make sure it still works. And now we have to do the no check-ins in this file. And these, I think I'm going to rename them from no check-in to test. Because I'm going to move those into a test program later, but it's not that important that I do. Like this also is a test program. This gets run every time we run the test. It's also like a demo, and I want to move the more grungy test stuff. Although, you know, this should be part of the demo, actually. The fact that these are... It'll just be at the end of the demo. Yeah, I'm not going to move it into a separate file. Yes, there is... The new feature that is dope has not yet been implemented, but what we are doing right now is on the road to the dope new feature. Wow, it's 9 p.m. already. I feel like I just started my day. Uh-oh, I have to sneeze. I feel like I just started my sneeze. Yeah. Yeah, wait, why am I running debug? This is not even the right tests, guys. Okay. This is good. This is good. So we're going to check this in. No, not that. This. Progress on pointer literals. Remove LVM header from obj writer on Windows. Well, fixed some operators not detecting invalid float arguments. Whatever. That's not a good description, but it's fine. Boom. What would I say is my favorite feature? The C++ or other languages don't have the compile time execution. The full unlimited compile time execution is great. Okay. Well, what I want to do now, let's keep going on this. Oh, I forgot. Wait, I guess we're not running these when. Oh, this has to manually be added to the frickin' thing. See, it's not in that. Okay. Okay, we should automate that at some point. Okay, this is going to go away and okay. I forgot that that is manual. Okay, so as we run this, though, you see that, well, many of these things are constant, but address of any global variable is not. My theory is, this is easy. My hope is that I could do this one, actually, let's see what those are before we get excited. Yeah, that one, that one. This one is not supposed to be constant, and so is that. And then maybe that one. And maybe even that one if I stay up super late. We'll see. It depends on how well it goes. Oh yeah, I can delete the A and B. Good point. Wait, where were those? Down there. Okay. Address of any global variable. Well, if it's a unary operator, okay, if it's address of something, that's fine. So this is actually, so the unary star operator, which takes the address of things, also is like a type operator, right? So for operating on types, we set this type version thing, right? And if it's the type version, we do this. Otherwise, we do this. Okay. Okay, so is global storage declaration, okay. Okay, if we want to basically do this kind of thing. So if it's final, we have a constant, we say global symbol on unary and, well, pointer. We probably, okay, we already have this type here, yeah. right? Else, we could put this down here. What happens if we fall? Yeah, it just returns true down there. No big deal. We make a pointer literal. Global symbol. Set the substitution. Boom. Is it that easy? I don't know. We should actually run and debug so that people can assert, but let's just see what happens if we run it. Address of any global variable, constant. I mean, what more do you want? What more do you want than that? Well, you would like to know that it actually works, so that's a thing. Address of any global. Right. So global int actually no, like it has to be constant because it's in there, so we don't need to print this. So we're going to say equals 1 2 3 print global int is whatever, right? And that should be 1 2 3. Ta-da! Let's try x64. It shouldn't matter for this, but we're doing it. Ta-da! See, that's how easy life can be if things are reasonable. Okay. So we're actually kind of far down. Is it weird to talk myself for hours on end? It's a little weird, but I'm a weird person, so that's okay. That's okay. So this is something that people were asking for, like on Discord or wherever, right? The ability to do this. Which is one of the reasons why it would have been nice to get this into the beta, and why it is nice that we are getting it into the beta. What is wrong with C++? Nothing. It's great. Yeah, C++ is the best programming language. The end. End of story. In the year 5000, we will still be programming in C++. Okay, great. Great. pointer math on a constant pointer. All right. Subscripting and dereferencing are not going to be, yeah. And then, but this one shouldn't be called dereferencing. It should be called reading members of struct literals. You will be able to do. You cannot do it yet, but you will. You should also do like right there. It gives us a few more to do. So this should be constant, these should not, and these should. So we're not quite done, but we're doing all right. Put one UI here. Okay. Where was I working before I wrote Braid? I was just contracting around at various game companies. So I sort of worked for myself and sort of traveled and, you know, did jobs for other people. When am I going to do another movie review with Casey? When I watch one, I need to watch something. We have an idea of what that thing might be, but I haven't seen it. Are there any good new movies? I doubt it, but it is what it is. Okay, so, I mean, let's make sure the tests work, actually, because any one of these things, if I screwed something up, could theoretically break tests, although I'm not sure that the probability of that is super high. We should check it. Looks fine. Okay. So, yeah. Next thing on the list was pointer math on a constant pointer. Check for pointer math. I feel like I didn't think enough about constant pointers, and we might have some confusion about the compiler thinking that constant or relative pointers are constant when they can't really be, or they can. I don't know, dude. I need to think of it. It's confusing. It's confusing. All right, pointer math. Okay. okay, if it's minus or plus, right. Actually, we have to break the pointer test into two, because pointer minus pointer is a weird, unless it's itself, which I don't even want to get into. Okay, so we're going to say pointer addition between a pointer and a constant, pointer math between a pointer and any other pointer, right? This one is not going to be constant, all right? Maybe const x per binary operation. Like, see, these things are factored weird. Is that the only calling site? No. Of course it's not. Of course it's not. Also, what about evaluates to true? Oh, I already did it. We forgot global symbol. Oh, actually, no, we didn't. It's down here, right? I already did all this. Great. No wonder things still work. So the deal is, I sort of call out to this other place to maybe do constant expression evaluation on all these different things, but like, we already sort of detect, oh man, like I kind of want to keep it here. Let's make it work and then decide how to factor it. All right, so when we decided pointer math, we have check for pointer math. Right. Okay. Oh, geez. This is going to be a little bit. Like, should I let people add things to null? Like, what practically, because the problem is that's a mistake that might happen commonly that you would like to catch. Like, if you say null plus 3, I mean, that is actually a thing that people could do. Null is just 0. Yeah, it is. Well, it's in C++, it's just 0. Here, it's a little bit different. Here, so because we have a pointer literal type, null is now a pointer literal with constant address 0. Let's just break this out. I'm going to break it out like this. We're going to do plus and okay, first of all, we need literals for both sides. Yeah. We need both of these. Okay. Yeah. Okay. So we have the pointer on the left. This has to be a pointer. All right. And I guess all right. So this is such a pain. Such a pain. All right. We have to deal with signed and unsigned and all kinds of poopy things. Okay. Otherwise, it's U64, except I mean, do we really? Let's just do this. Because we're going to truncate it to S32 anyway. If it's out of range, will that actually work? All right, so if we're not out of range, we actually do the thing. Although actually, see, that's not even good. Frack. Frackety, jackety, badackety. So the thing is, okay. This I can call into this after I factor it out, so that's going to be fine. There's actually two cases. There's the constant value case and the any other case. So offset from symbol should be signed. So what we actually care about is if this is going to overflow, not if this is going to overflow, right? So much beta spam did I find in the DMs? There was a significant amount. I haven't even gotten through all the DMs. I'm like up to November now. Even the guy who invented null pointers said they were a mistake. That guy is not a systems programmer. People who say you shouldn't have null are kind of nuts. It's like people who say you should have communism because everybody will have equal. It's like, okay, but you're not actually thinking about the details here. It's like, look, Pascal didn't have... Actually, Pascal did have null pointers. Never mind. You don't mind the Rust approach, but it can be kind of annoying sometimes. Well, it's even more annoying if you don't buy into certain other things, which I don't buy into. CAR Horror is not a systems programmer. Is that who said that? I mean, okay, I'll put it this way. I would like to see his proposal for how to make an efficient operating system that doesn't use null pointers, right? And the problem is, like here, let me try to explain the problem, right? The problem is not where you think it is, right? So you think the problem is just, oh, well, every time maybe I want to use a pointer, I have to like unwrap it. It's like a maybe null or whatever, right? The problem is you would like to say, okay, well, after something is known to not be a maybe null, right, you could store that into a thing that's definitely not null, so you don't take that hit. And you know, the language only allows you to do that after you've unwrapped that particular pointer, right? So there's all this machinery involved in that. But the problem is that doesn't actually work, because to make a powerful system, you need to actually say this thing, this pointer is a pointer to data of type X, and return it. Otherwise, you can't make a memory allocator, for example, right? Now, as soon as you say this data is pointed to and it's type X, that might have fields that are null, that are claiming not to be null, right? Or in fact, they could be uninitialized or whatever. And so you have no like ability to initialize those things unless you have some other kind of exceptional syntax where you're like, I'm about to make this thing be a pointer to this, and in the process of doing that, I'm going to set the following fields so that they're not null, right? You need to have a way for those things never, ever, ever to be null. You know, maybe there's a way to do it. Like, you know, I could certainly sit down one day and try to map out what all of that means. But like, it's not as simple as people think it is, right? And see, here's the other thing, is that null pointers, they definitely do cause problems, but the problems are much worse in some domains. Like, you know, like in the games that we work on, we pay almost no cost. Like null pointer issues just don't really come up that much because whoever wrote a system like tested it before it goes out. Like like if you were to list our top 100 problems, I don't think null pointers is on that list. Maybe in 100, but certainly not in the top 20. Like there's so many things we need to improve before worrying about null pointers. So, you know. Now that said, if you hire the summer intern and have them write engine code, they're probably going to make a lot of null pointer mistakes. So there is that. It's like, it's a different scenario. Hire me as your summer intern. Yeah, no. The thing you like about a type that can either be a type or null is it reminds you it's possible for this thing to be invalid. Yeah, totally. I mean, the question is just, for me, can that be done in the systems kind of way that we need to do it for games, in a way that doesn't make it a giant frickin' headache all the time, right? Maybe. I could imagine that being the case, but it's not obvious, and people don't, because everybody buys into this like constructor kind of paradigm. Like if you're object oriented, right, which I'm not, then you have this idea like, oh, as soon as something's returned from the constructor, it's in a valid state, and that's when you know that the things are not null. But that turns into a giant disaster. That whole idea doesn't work for large and complex programs. So, that's why we don't have constructors in this language now, because that just wasn't good. What do I think is the best way to learn? Just try programming whatever you're the most interested in. Like, just follow your interest, and that'll hopefully go somewhere good. But yeah, like I understand why he calls null pointer the $1 billion mistake, but I also do, it's just not that simple, is what I'm saying. It's not actually that simple, because the costs that people pay, like the pattern that we see over and over, is that people try to solve a problem, and the cost that they pay in solving a problem is very often worse than the problem, right? It sounds simple to solve null pointers, but it really, like, I don't want to program in Rust, right? And there's reasons why. It was a mistake to make cars that crash. Yeah, I mean, that's a little bit of a facetious analogy, but yeah, sort of. It's just like, if you start putting that kind of annotation, for example, in structs, like this thing can't be null. it's unclear how lightweight that can be made in terms of how hard you have to think about it, right? And deal with it. Yeah, we'll see. I mean, I haven't written that off. Like, it's on my list of things to think about, but every time I think about it, I'm just like, it's not. Am I Team Apple or Team Epic? I'm Team Epic, basically, on that whole issue. Okay, I want to get back to this because this is going to turn into a giant swamp very quickly. Like, dude, signed versus unsigned is itself a giant pain. You know, I could actually, I was thinking about some shortcuts I could do, but how's it going? How's it going? I hope good. Yeah. I really don't like what I'm about to have to program. It's just gross. It's not actually complicated. It's just gross. It's way more code than it should be for what it is. But I'm just going to do it. I'm just going to 420 blaze it, but without the 420 part. I mean, oh, it's so gross, dude. All right, hold on. No. So the thing is, based on, we could have info dot pointer, let's say auto PL type is info dot pointer literal type, just to have a name for it. If PL type is equal to PL global symbol, no, PL constant value, right? We do one thing, otherwise we do another thing. And the problem is, it's freaking different either way. Okay, here's what we're going to do. We're going to make this signed for now because it's going to make this easier. We're going to say old offset equals info dot values dot constant value. Otherwise, it is info dot offset from symbol. And, you know, maybe that should just be S64 and right there. You know, like, I'm sort of trying to make pointer literal info small, but no, let's just do it. Let's, yeah, because I already said maybe I need more range. Okay. Okay, great. So, boom. You know what? Now we have to fix the rest of the program because I just broke some things by taking that out. So let's do that. Reward myself with a nice steak after. That is a good idea, but I don't know where to go to get nice steak in San Francisco. Especially because it's illegal to go to an indoor restaurant here still, because we're living in communist Russo China, which is one reason why I've been gone most of the last month, but I am back for a little bit. Ruth's Chris. Better than the Sizzler, man. All right. Wait. Okay, all these constant values are what I just did. So why don't we just search for those? Arrow constant value, and we want to change that dot constant value. We want to change that to offset from symbol. Oh. We could actually do a global replace, right? Let's try this. This is cheeky because there might be something I'm not thinking of, but we're just going to do this. Replace them all. And mistakes are all my fault. Okay, this is, maybe we just fixed it all. Okay, value type is not a member of expression, right? Okay, this is not. We don't want order constant because that makes it an expression. We just want literal. Oh, yeah, okay. PL type double equal is not a thing there. You're surprised San Francisco hasn't had riots yet? Yeah, I mean, the problem is all the tech programmers are just wusses. What is my favorite TV show? I honestly don't know. Favorite TV show? I mean, the original Cosmos is pretty good. It's hard to say. Are there no steakhouses in San Francisco with rooftop outdoor seating? I don't know. I just would have to do extensive research to find them. Do I have any non-computer related hobbies? Is dancing computer related? I don't think it is, but it might be. All right. We're just running tests here. Does Tiger King count as a TV show, or is that just like, I don't know what that is. Tight mismatch between arguments of operator plus. That's because the code that we just inserted is preventing us from doing the other things, because we sort of guess. I guess this takes it upon itself this actually shouldn't be necessary. We actually can do that. I'm changing all kinds of random things that have nothing to do with what's actually important. Make sure I've got it's just 2 arguments. So the reason I'm using this is because long term, it's probably not going to be stored on the nodes, so we have to switch them all over to a function call anyway. And and set substitution not found. Oh. I need to fix that. Really? It's on typer. Oh my God. This might have been a disaster. You know what? I'm just digging myself a deeper hole. Okay, we're going to do another. We're going to go replace everywhere. Set subs. This is going to be really painful. I'm going to replace all that. And the reason I did the underscore here was so it wouldn't replace that. Okay. Oh my God, the get. Okay, we don't actually need this, thankfully. Okay, so this has nothing to do with what I wanted to work on. Oh my gosh. Oh my gosh. Okay. So many fallouts. Oh, typer still has its set subst. Boom, gone. Oh, I forgot the... What was it in typer though? Defaulted to true, so default to true. Great. Does it blend? It's going. We're still going to fail the test though, because we didn't fix that. When we get to our 551 test, that's still going to break. Because I was over here looking at this and like, yeah, I guess we'll just punt right now, like, actually, we could just fall through. Instead of this being in else, I think we could just do that. Oh. That's a little weird. Okay. Oh, guys, I'm stupid. This is an actual bug. This is not... like... These are not the same. You can't add 2 pointers of different types. I'm all sitting here acting like I goofed. And I didn't. Well, I did, but I goofed over here and not over there. Okay. Other global int. Those are going to be the same type. The whole point. Oh, P is casted. This won't even work because P... mistakes were made. Whoa, really? Baked literals match exactly. So, well, let's just see. Oh, wait, I didn't. Yeah. Well, we found a problem. Protocol. What is? Do I even want to ask what is protocol oriented? Am I just going to baby rage when I hear about what protocol oriented programming is? What is going on? Oh. Protocol is a Swift Objective-C name for interfaces. Basically, don't subclass use inter. Why is that an orientation? That's just a language feature. I guess if you're in charge of marketing Swift and telling people why it's so great, you say it's based on POOP, aka protocol oriented programming. Yeah, so obviously this is null. I'm not sure why. I'm not sure where this literal came from. Line 134. Well, obviously that's what I was doing, right? Are we failing to copy things in copy literal? I don't know. Wow, this is, as soon as you add a breakpoint, you're asking for trouble. All right. Where does this literal come from? Copy literal. That's what I thought. Okay, but okay, this should copy should copy the pointer literal info. Maybe I just haven't thought about this clearly enough. So literal values, pointer literal info, global symbol, and here. And then the thing that's in here shouldn't ever get freed. Maybe that's not getting copied for some reason, or maybe it's getting reset. Let's see, result. Okay. Result. It's a pointer literal. The values. Pointer literal info. The values. Global symbol is a thing. So does this get corrupted? Maybe. Did I get that right? Yep. Three, 5, 6, 4, 1, 9, 8. And then we'll disable this one so we can go fast. Bro! Why are you setting this like it was an integer? Bro. Wait, what? Pointer math. False. Why are you telling me this isn't pointer math? This got substituted to a literal. Oh, because, okay. The thing that detects pointer math doesn't know about wait. What? Oh, pointer 2. So, why? What? I don't. Something is happening that's probably very simple. Dude, this is the worst UI. Did you guys see what happened there? Like I was scrolling, and then it popped up over something like that, and then I was scrolling that with the mouse wheel, and it can't scroll anymore because it popped up a stupid craplet that I don't care about, and then I move off it. There we go. Like why isn't everybody fired who ever had anything to do with this? All right. All right, so we have 2 pointers. Oh, that's why. Right, okay. You can't add pointers at all. We should just error that. That's like not a thing. Pointer plus pointer is not a thing. So this is another case of us well, pointer minus pointer is a thing, right? Okay, so 3542. What we really want to say is if they're both pointers, if it's minus else, that's just not a thing. Okay. So that just means my whole test case is stupid because, oh, debug. It's stupid because it's not legal in the first place. So that's good though, because we found that that wasn't being detected, right? Okay, but we could do pointer subtraction. Pointer subtraction is just probably shouldn't be constant. Okay, so that actually makes it easier because I was thinking in my head that we were going to do pointer subtraction as constant, but we're not. Subtraction between 2 pointers is not constant, but addition, subtraction between a pointer and a constant is a constant. Okay. So we need to go back and do this now. All right. Old offset. How do I do range checking against something that is either signed or unsigned, right? Without, I mean, I could just check the overflow flag if we were in assembly. I mean, with the unsigned value, I can check that if the result is less than the original value, right? Okay. We're going to say S64 new offset, right? So new offset equals old offset plus this, all right? If new offset is less than old offset, right? Because it should only go up due to adding a U64. All right. Okay, so here we're just going to say old offset, right? And then if off is equal to plus, we do this, else like, does C++ even do this right? Like signed plus or minus unsigned? Okay. How, there's rating people. What's going on, rating people? This is very exciting. People with weird eyeballs in the chat. Okay. Well, I'm not sure how to detect overflow here. I've done this so many times in so many different contexts that I should just frickin' know. I should just know what to do, right? So now, is it even more of a pain in the butt because I have to check the sign of this and out of range if it's in the wrong direction from the sign? Like, this is trivial in assembly, what I'm trying to do, right? Those are your eyeballs. Well, that's a problem. I mean, I would recommend seeing a doctor, except it's COVID virus time, and that might make the eyeballs even weirder. So, okay, I'm sure, dude. Hacker's Delight would tell me how to do this, right? What would Hacker's Delight say? Oh, wait. Negative integer means it is explicitly less than 0. I know that for a fact. Okay. Great. If we are not out of range, then the new offset is good. Yes, auto. That actually wasn't as painful. I mean, if it's right, I don't know. Make pointer literal. Maybe I shouldn't even do a range check, right? Like maybe if you overflow. I don't actually know. So we want PL constant value with and the inferred type, which is like that. Something like that. Let's say set substitution. Oh yeah, we just did that. We added that argument just now. Just now. Alrighty. Okay, I didn't see my info report. That makes me upset. Why not? Oh, because we're running the wrong executable again. Because I did the wrong thing. There we go. Constant pointer up, constant pointer up. Thank you. Constant pointer. Oh, I didn't even realize that would work already. Pointer addition or subtraction between a pointer and a constant. Okay, that is working. Question. Is it actually working? It's working in the sense that it is constant. Is it working in the sense that we can use it in the right way? So if I say So constant pointer cast to another pointer type is also, that's interesting. I didn't realize that was going to work. This shouldn't frickin' work, actually. Hold on. I'm going to make this one a no check-in because that's important, because that will introduce bugs. Okay. That's bad news bears. But this one, all right. So basically we're using a compile time known constant pointer, putting 111 in there. Yep, constant pointer op right there. Okay. That didn't work. But this might actually be wrong. Because I didn't do that intentionally, so. Yeah, okay, so why? Oh, we never set the frickin' value, guys. If you want to succeed in the game industry, I don't even know, man. Dots. If you want to succeed in the game industry, don't be a zero, is what I would say. Okay. That. Oh. I assumed. Okay, this is actually, we need to make it the same type as literal left. PL type. Okay, and if actually, we'll just do this. Equals just info. This will copy the values subfield containing whatever global we are offset from, if applicable. Just don't forget to do the code that makes the code work. All right, that didn't work. Oh. Wait. This has nothing to do with what we were. Hold on. This is a different problem. This is us getting further in the system. JCC and Clang have intrinsics? Yeah, maybe. Maybe that's the case. All right. Emit stack pointer. Oh, we're here again. This is a thing I need to clean up. Literal. Global symbol. Okay, I did the wrong thing here. I fixed this one. And I didn't fix this one. And I'm sure the backends don't probably do this correctly. Although maybe, we'll see. Actually, these could honestly be the same. Almost, just not quite. Okay. Hey, look. We added the wrong amount. What? How did we, wait, we said x plus 10. And we got plus 8. We said x plus 10, and we got plus 8. I don't think backing will matter, but it might. No. What? Oh, maybe. No. Oh, this might be a thing about the linker refusing to do it because it's not. No, this is a pointer to U8. It shouldn't have weirdo alignment. What is going on? Okay, well. Well, we will find out. Okay, new offset is 2, 10, decimal 10, 10, 10, 10, 2. Okay, y is x plus 10. Delta is y minus x. Print delta is equal to whatever. Eight. Okay, guys. We have proven here today, brand new world exclusive, that 8 is equal to 10, which I'm sure after a small amount of additional work, you can then use to prove that 2 plus 2 equals 5, right? I'm pretty sure that you could factor that around pretty straightforwardly. And then that means all those people on Twitter were right. 2 plus 2 does equal 5. How could we have ever doubted that? I'm canceled. No, I'm non-canceled. Is an egg a fruit or vegetable? That's a very difficult question. I think it's a vegetable, obviously, because it's eggplant. Everybody knows that. Everybody knows about eggplants. Don't try to trick us. Do I do any martial arts? I used to, but I wouldn't say these days that I do. Okay, what is going on? Well, also BTW, I forgot to multiply by the size. I just realized for pointer subtraction, that's a weirdo one. Okay, so that shouldn't matter here because size is 1 for this, in theory. Okay. Global symbol. Offset from symbol. If offset, we emit scope entry eval. We don't say finish plug register, which we, I think, need to do. Uh-oh. I don't think that's the problem, but yeah, we're supposed to say finish plug register, I think. So I passed the same type both times. Yeah, that's goofball. I know why I did that, but I'm a goofball for that. I do not think that will matter. We'll do it anyway. And see that it doesn't change anything. And then figure out what to do from there. Delta is still 8. 8 equals 10. A is B. Oh, it's because I put the wrong... It's a copy and paste error. Error. Because pointer size is 8, that's why. And it just happens to be that 8 is close to 10. Delta is 80 because we're multiplying by 8 for some reason. Why are we... This size should have been... Oh, pointer 2. See, we've just got 8s coming this way and going that way. It's like the guys who invented the Bagua know that it's a thing. Okay, look, it's 10. Look, and it's auspicious. We got basically, if you're in the casino where I was in Vegas, that's a really good number to get to come up on the wheels. Are we doing pointers and constants? Yes. 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 How do you deal with pointers behind pointers in constants? Do you set them at startup? Pointers behind pointers in constants. I think you would have to be more specific about the use case that you're talking about, because I'm not sure what you mean. Like a lot of the time that you have a constant pointer. So constant pointer just means it's, you know, it's known well, like it's known at compile time or kind of known at compile time, by which I mean that the linker will patch it to the right number, right? You don't know what that's pointing at. So you don't necessarily know the contents of the pointer at compile time. I mean, you can look at literals and stuff like that, but not necessarily through pointers. When you have a pointer and a constant, you have to offset it by the executable position when handling. No, the linker figures that out, right? You don't have to do that manually. The linker does that for you. It's the same, look, like a function pointer in any like C style programming language is a pointer in a constant. It just happens to point to a place in code that you would jump, right? But you could do that same thing for data. And what we're doing right now is guaranteeing that in the language semantics, that works on data. And then we're adding a little bit. So like, you could add an offset to that pointer and it still counts, for example. Right? That's what we were just testing here. So y is x plus 10 and x and y are both known at compile time. And that worked in LLVM and works in x64. Does it work by virtual address space magic so that no matter where the executable is loaded in, the constant pointers are always... No, it's not virtual address space magic. It's just regular linker stuff. Like again, in order for your program to work correctly, when the loader, for example, does address space layout randomization, which is what maybe part of what you're thinking of, right? It has to fix up pointers in the executable by itself, like when it does that, right? So what happens is whenever you have a program with pointers in it, even if they're function pointers, that function pointer has a little record that says at this location, there is stored a pointer that is n bytes into this segment over here, right? And then the address space layout or the linker or whoever says, okay, this segment, I'm going to put it at that location. So now I have to iterate over all these things that tell me where all the pointers are, and I have to fix up those pointers to point at the right things. And that exists on basically all operating systems. So we're just taking advantage of that and exposing that in the language semantics, right? That's just a thing. Like C programs have been doing that since 1970 or whatever. Not really since 1970, because back then the compiler would just assign values to things. But, you know, certainly since the 80s, this is how it's worked. So it really is not anything unusual. When loading the executable, the operating system does all the work for you to set up the pointers. Yeah, I mean, it is a substantial amount of work in the compiler to do this, right? You have to tell the operating system where the pointers are, and that's a pain in the butt sometimes. But yes, once you do that, the OS will like, it has to. Like, programs wouldn't run if it didn't do that. Now, that said, it is unusual. Like, I don't know of any other programming language that does what I'm doing here. There might be some. There probably are some. I just don't know of one. In fact, C++ might actually do this now. Like, I know that it's in the language spec, like what counts as a constant expression and what doesn't. And for example, I don't know if in C++ the address of a global counts as a constant expression. But it does here now as of today. Okay, so we have to fix these though. Constant pointer cast to an integer is no bueno. No bueno. I mean, not as a constant, right? Like, for example, I guarantee, so if I do this, int y is cast to int of y, that's going to be, actually, that'll work because it's non-constant, right? But int y constant, I believe we're allowing this, but this will be the wrong answer because it's a bug. How did that work? How did that even work? Okay, it must still be a pointer literal. Like, what? Okay, actually, no, these are both wrong. Both of these are wrong. Which is bad. That's why. Because This is a large number, and that is not a large number. Okay. So we have a little more work to do here. I actually just want to break in there to see what happens, because I feel like the number flags are not things that I want them to be. So line 207. Maybe this isn't even where we're going through, but okay. I'm getting tired. We're getting close to the end of the stream. Did I say 207? 207. All right. The reason these are the same is that it's const expering this anyway, even though this declaration is non-constant. It's doing this at compile time anyway. Right now. Wait, what? What? Are we not? Come on, bro. Okay. End of the stream. Yeah, I'm not one of those pro streamers that goes 12, 24, 36 hours. String builder, wrong file. Always check the file. Okay. Is it a literal? Yes. Okay. We really should just clean that up to whatever. We're not going to orient it yet. Okay, so it's a literal. We're casting to an integer, right? This is for casting to pointer. So I'm a little not sure about what's going on there. Okay. See, I thought I just set a breakpoint in there. Why didn't we hit it? Okay, let's just get inferred type. That's not what we actually care about. Okay. $197. Because that's where it was generated. Okay. Right. Yes. So the literal is made here, but the cat, right. This makes sense to me now. It all makes sense. Okay. I don't like that these... Don't like this. Oh. I see. I see what happened. Okay. Okay. let's just do this. I think that'll just solve the problem. See, it did. Like, it's saying you can't do this because this is not constant, so you cannot do that. But if I say pointer to int, then I could do it. Okay, so pointer to int is this. That's the right number. This is probably the same number. Let's just make sure. Yep. So we can cast the integer correctly. Okay, so constant pointer, cast to another pointer type, Gucci. Constant pointer, cast to an integer, non-Gucci. These are all fine. So I think we're going to call the stream soon. We can do some final questions, but we didn't get to these tonight. That's fine. It's fine. We will. These should be pretty easy, I hope. Actually, I'm actually not sure about some of these. Like I think the way that I'm doing some of this stuff. So, Foozle is address of global buffer sub 10. I don't think that'll work. Yeah. So I need to actually fix this. So the thing is, the way that I'm doing this is we're actually evaluating that, I think. I don't know. This should work. Because you don't want, obviously, you don't want things to just break for no reason. Oh, you know, right. I mean, that'll work, right? It just won't, right. So address of a subscript of a global array. What about an array literal? Like, oh, there's so many different things. Like, does that, I don't think that'll work. Yeah. Should that work? Maybe. All right, We're doing pretty good, though. We got some stuff done today. Okay, and we actually got this incomplete because constant pointer cast to an integer is not constant. And that was a no check-in, so we get to delete that. Should that have the same semantics as y? Yeah, I mean, basically the address of a subscript is, yeah. It's just the constant expression evaluator has to know how to recognize these things. And they fight a little bit, right? Because, you know, we don't do these things top down. We do them sort of bottom up. And so we see G sub 3. Oh, actually, we don't. Right. If this is a literal, we do subscript it, right? That's kind of like this is actually a constant, right? So if I say G sub C, where C is a constant, that is constant as well. And we give you back the actual value in this array at compile time, which you want, right? That's a very valuable thing to not have to spend runtime CPU on that. The problem is the way we do, this happens during the type inference phase. So we actually do this and substitute the constant. And then we say, oh, and then they want the address of that. So that's why the error message was saying, trying to take the address of something that doesn't have a, right? And so I think that can be dealt with. I mean, you could flag the thing under when we flatten. The problem is just we have to remember to propagate that through macro expansions and stuff. Anyway, but that's fine because once it's implemented, it goes into a test, and then if the test breaks, then people are upset. Ship beta did not happen. That is the case. Ship beta did not happen. We're not that far from shipping beta, though. Honestly, like I want to fix a couple things here. I want to make these work, right? And then I want to make these incompletes are okay. I'm not that worried about those. In fact, these are okay. Like really what I want to do is just do this and then give it a couple days of just testing to make sure that I didn't do something really stupid. Of just, you know, random, like, hey, we're programming, does anything bad happen? And then we'll ship the beta. I do think it's pretty cool that we can like do this and it's still like, you can just keep adding and subtracting numbers and it's just a constant, right? That's pretty great. I mean, this is sort of, though, it's sort of a stunt in the sense that, like, I don't know how important that's actually going to be. Like, I think it's pretty useful to be able to take the address of a global and have that be constant. But, like, to do math on it and have that be constant, it's like if I decided not to do that, things would be simpler. A quote constant. Yeah, I mean, it's a quote constant, unquote. It's the type of stuff you do for version 59. Yeah, I mean, we're on beta 25 or something, so. Well, if this ends up being too much of a hassle, I'll just take out the offsets. And it'll just be addresses of globals. But Should you be able to apply the same thing to locals? No, because locals are on the stack, and the position on the stack is not known, and in fact may change every time a procedure is called. So locals are not constant. Absolutely not. Address of variable x won't change during a function call. Yeah, but like constant means it's in the machine code, right? Effectively. I mean, never mind the fact that it probably gets loaded from memory on x64 or most modern processors because it's a huge number. But it's effectively baked into the machine code when it's constant. So, like, you'd have to be changing your code on entry to the function, which sort of would invalidate any of the point of all this. This has been fun to work on. Like sometimes, like with this offset thing, I'm like, yeah, that's maybe not going to be super practical. But actually it might. Actually, no, it is. I forgot. There's a really good reason to put that in. It's part of the super feature, the killer awesome feature. So, yeah. Okay, thanks everybody for coming by. I don't think we're going to raid anyone tonight. It's late. We're not going to play games. We've been streaming for, did we make 8 hours? No, 7:46. That's a pretty long stream for me, though. Thanks to everybody for coming by, and I'll see you later on.